welcome. So good to see a bunch of people. Should be recording. How are we doing? Great. All right. Come on in. Welcome. This is the Solar Decathlon Competition Event 2022 Design Challenge Division presentations in the Multifamily Building Division. If you did not intend to be sitting in the Multifamily Building Division, we won't be offended. You can stand up and go to another room. But we are so glad that you're here. Glad to finally be doing things in person, although we are also, we're hybrid, we're doing this virtually as well, so we want to include those who are remoting in, and we see a few folks, so welcome to you as well. If you have any issues with technology, please do chat. Maddie will be on all of the things behind the scenes, and she is ready to try to help you out. And what else? My name is Zoe Kaufman, and I am the jury coordinator for this division. So each and every one of our teams has worked very hard up to this point on their design projects, and will present an 8-minute presentation to our juror industry experts. And based on the presentations of the semifinal competition in February, only 10 finalists have advanced to compete at this final stage of the competition. So congratulations. So a few housekeeping items. If you are on Zoom, please mute yourselves whenever you don't intend to be talking to our entire room. And if you're here, just try to respect everybody who's up at the front. But you know how to do that, so great. Welcome, welcome. You can find seats. There are a couple left. All right, so the presentation format is, as I said, an 8-minute presentation. We will be timing. So you will see, Maddie will have cards for you that will show a 5-minute warning, a 2-minute warning, and when your time is up, you will know it because you will hear a loud buzz from the buzzer. So please stop at that time. Everybody was great though in the semifinals, so you can do it again. And then we'll have a 15-minute Q&A from our jurors, and then we'll move on to the next team. Our schedule for today and tomorrow, if I can pull it up. Here we go. So we have division presentations. There will be a short break in between, and then there will be lunch at noon in the cafe. The cafe is over there. Maybe you already got breakfast. You will know where it is. We will all guide you over there. Then you'll meet back here again for division presentations, and then there will be another short break and then more division presentations. There's also at 4 o'clock organized networking with some appetizers as well, also in the cafe. So that will be the end of the day today. And then tomorrow, everything is in the Denver Marriott West at the Golden Ballroom. So you'll have breakfast again at 7:30, and then the Design Challenge Division Awards and Build Challenge Approval to proceed. And then there's an alumni panel, and then a break and networking, and then there will be Design Challenge grand jury presentations. So if you do very well here, then you will have a chance to present for the grand jury. And then there's lunch and the 20th anniversary of Solar Decathlon celebration. So it has been 20 years of Solar Decathlon. I actually participated, not 20 years ago, but about 7 years ago when it was the Race to Zero. So I was in your spot not too long ago. And then the Design Challenge Grand Winner Awards, and that will conclude tomorrow. Oh, it already advanced. Interesting. Okay. So now we'll introduce today's jurors. This is our panel of industry experts. They have also worked very hard in reviewing all of your submissions and taking time out of their schedules, so we really appreciate them participating as well. So first up, we have Michael Kramer. Michael is a senior building science specialist with comprehensive experience leading both new and existing buildings projects at RDH. His meticulous and detail-oriented approach can be attributed to his knowledge of building science and his industry expertise. Along with applying his building science focus to assess the relationships between sustainable buildings, building durability, and building codes, Michael is also the co-regional manager of RDH's Seattle office. His past achievements include being a member of the City of Seattle Green Building team that developed Seattle's groundbreaking sustainable building policy, the first municipal policy of its kind to adopt the U.S. Green Building Council's LEED Green Building rating system. Michael is a LEED accredited professional and holds memberships with the National Institute of Building Sciences and the Seattle Building Enclosure Council. All right, we'll go in order of seating. Next, we have Reginald Truxton. Reggie is the president of the DC chapter of the National Organization of Minority Architects and an associate at Gensler. Reggie serves as Gensler's Southeast Region design management leader, providing guidance for the firm's design managers to strengthen the foundation of its business. A leader in large-scale multifamily projects, he has a keen ability to manage complex projects and maintain quality design product, all while driving both alignment and client satisfaction. Reggie helped establish a resource group for Gensler's Black employees and is a regional race and diversity co-leader for the firm, where he organizes projects and people to make a lasting positive impact on the state of diversity, equity, and inclusion in the industry. Next, we have Alexander Person. Alexander works at the Smith Group in Denver's office. And Alexander, maybe you want to do a short introduction of yourself because we didn't get a bio from you.
Sure, good morning. I currently am an urban designer and architect at Smith Group. I work in multifamily and also higher education. My passion is creating places that people love. I'm the former president of the Congress of New Urbanism, and I am also a member of the National Organization of Minority Architects here in Denver, Colorado.
Thank you. Great. And finally, we have Bryce LeConte. Bryce is a lifelong entrepreneur with a passion for building socially active companies. He is the founder of iUnit, a real estate development technology company focusing on building energy-efficient, smart, modular communities. iUnit is proud to have built Denver's first sustainable, attainable modular apartment community and has several other communities in works, including an off-grid staff housing community. He received a Master of Science degree in Real Estate Development from Johns Hopkins University and an undergraduate degree from the Smith Business School at the University of Maryland. He is a frequent speaker and panelist and enjoys investing and mentoring early-stage startups. All right, so now I just want to go through the order of our presentations today. If I can find my schedule. Perfect. Okay. So first up, we have Technische Universität Berlin. Then we have the Wentworth Institute of Technology. Then we'll have a short break. Then we'll have the University of Illinois Urbana-Champaign, University of Cincinnati, and Cooper Union. And then we'll have lunch, and then we'll come back here, and there will be University of Missouri, Ryerson University, a short break, the University of Arizona, University of North Texas, and then finally Northwestern University. So with that, I think we can begin our presentations. Just a note for the presenters, when you're up here, you have to be fairly close to the microphone, so you can either switch places here or pass the microphone off. We would appreciate if you would stand within this black line that we've made on the floor so that you can be picked up by the camera and everybody remotely can see you. We will give you a clicker and you can advance your slides that way if you wish. We have all of our teams here, I believe, so this is really exciting. Hopefully we won't have to coordinate too much remotely, but if there are team members who want to help you answer questions, they can feel free to unmute during the Q&A session and help you answer juror questions. So that said, I will stop talking. Technische Universität Berlin, please come up.
Hello, hello.
Right, I want to make sure everything still works.
Yep.
Jurors, are you ready?
So,
All right. Are you ready? Team, are you ready?
yep.
All right.
Hello, everyone. My name is Neil. I, along with Amin and Shurad, will be representing Team Greenbau from Technische Universität Berlin for Anja Elba. We are diverse, coming from 7 countries across 3 continents. Our presentation is structured in 7 chapters, starting with our project goals and ending with our financial projections. We began the project by setting 3 goals. First, we wanted to integrate the senior residents within an environment with the younger residents in an urban community. At the same time, we also wanted to have a direct connection with the nature. But as we strongly stress on this point, we also wanted to have and design a project which is energy efficient and has an energy use intensity which is less than half of the set target. Our project is situated in the Hafen City area of Hamburg, Germany. The reason why we chose senior citizens as one of our target markets is because of the inverse funnel model of population that is happening in Germany. Because of this, the percentage population of senior residents is actually in Hamburg, which is 1/5, is going to increase to 1/3 in the estimated years to come. Because of this, Hafen City, having realized this, is also taking care of this by promoting the integration of senior citizens in the city center. Our project site is well connected by public transportation. There are several restaurants, parks, hospitals, public spaces, which are within our walking distance and a mile of the project. Now, Amin, could you please tell us more about how we designed our project?
Yeah, sure. So first we started with our site accessibility. It is accessed through the main road on the north and the river boardwalk on the south. We then proceeded to design the underground parking, which is accessed through the road on the east. That road has been adapted to accommodate delivery trucks for the retail units, which are spread across 2 floors above that. Later on, our next step was to define the final footprint of the building based on the dominant wind directions as well as the site connectivity. Later on, we expanded the volume of the building up 9 floors up for the residential areas in accordance with the Solar Decathlon regulations as well as the Hamburg urban construction law. Our final step was to reshape the volume of the building to ensure maximum exposure to sunlight as well as daylight for the entire units. And as you can see, the surrounding room continues vertically across the entire facade through the cross-laminated CLT balconies and terraces, offering an extra space for systems installations such as PV panels, as well as an outdoor area to enjoy the unobstructed views to the river and the city. Our building is very well connected to the surroundings through the bridge crossing the river Elbe on the south. And as you can see also, where the building has been split across the east-west facade, creating a gap for a perspective, the continuing perspective between the city and the river. We also added an inner courtyard acting as a semi-public space for the residents. It has been designed to host various retail activities, children's playground, as well as senior citizens recreational area. On the inside, all of our units have at least 2 exterior walls, offering the opportunity for cross ventilation as well as the daylight exposure to the unit. We use the vertical windows for better connectivity with the outside, as well as wider angle for the sun path to penetrate to the building. In total, we have 7 unit typologies, ranging from single occupancy to larger families to senior citizens. The senior citizens units have been scattered across the entire floor area for better integration with the community, and they have been placed on the first 3 floors of our building for easy access. Material-wise, everything will be designed using sustainable and recyclable materials made available by our partners. We'll be using CLT as our main construction material, and also solid bricks for the outside as a symbol and a reference to a Hamburg architectural identity. We also designed a hybrid structure combining RCC for the ground and subterranean floors and CLT for the remaining floors. So now that we discussed the design, Shiraz will tell us how we save energy.
This begins with passive strategies. Adding balconies to the south and optimizing the window sizes help reduce our lighting demand, but at the same time provide some thermal protection as well. For the residential areas, we use cross and stack ventilation, which in addition to the year-round cold climate, eliminates the requirement of cooling in the residential areas. The retail areas are ventilated mechanically with heat recovery, of course. Innovative, smart energy-saving techniques were incorporated into the system design. For example, a simple example would be the shower water runoff preheats the fresh incoming water. This preheated water is further heated by the district heating before being sent for domestic use. This process saves up to 15% of the hot water demand energy. The space heating is provided by district heating again, but through radiators. Another such example is the roof water, the rainwater collected from the roofs is sent into the underground area and is filtered before being sent for flushing purpose. This process saves over 198,000 gallons of water every year. We have over 350 panels on our rooftop as well. They help us generate over 121 megawatts of energy, electrical energy every year. That in addition with the dynamic load management systems help shave off our peak loads. The reversible heat pumps are also used for the retail areas, which provide year-round heating and cooling only for the retail areas, of course. And this uses the river alongside as the heat source and the sink. The minimum compliant baseline model of the project has a site EUR of 38.56. We were able to reduce with the improvement in the materials by 8%, the passive strategies by further 22%, and even to a lower amount by incorporating the system designs that we spoke of. In the end, after considering all the renewable energy systems, we reach a final source EUI of just over 7. The total energy savings are over 72% in this case. I'd like to point out to 2 main energy sources here, the PV and the district heating. The source of this district heating comes from the waste industrial heat of a copper industry just next to the district. Coming to the cost, the project definitely has a relatively higher side when it comes to the construction costs. However, the operation and the maintenance costs are extremely low and amount to around 63% lower cost for an inhabitant. Considering the life cycle costs and simple payback systems along with grants, from an investor's point of view, the payback would be 19 years. In the end, we hope to have communicated our objectives of integrating the old population with the young, linking the residents with the nature, and also designing an energy efficient building in Hamburg. We thank you for your time, and we also thank our sponsors, faculty, and our partners for their ongoing advance advices. We are now open to questions.
Thank you. Yours, feel free to ask as you wish.
Well, congratulations, and thanks for making a long trip to come present for us. It's a great project. So I'm very jealous of your district energy system, district heating system. I wish I had that here in the US to pick up a lot of load. Can you talk a little more about that district, about that system? And I'm just curious about the financial arrangement with the local jurisdiction.
Regarding the
district energy, the district heating. Just if you give me more details on how that's set up and
sure. So I'd like to take that question for me. The district heating, it has been in place in the district next to ours and is active from 2018. It is actually good enough to provide 2,500 households. That is that's the scale of the district heating that exists. It comes from a copper industry, and they have a lot of waste heat during this process, and not very, I don't know very much detail into that. However, a large number of heat exchangers help us extract the heat from this processes, and it is 2.5 kilometers or 1.5 miles away from the location of our project. When it comes to the cost part, yes, we definitely pay cost for this energy. However, it's not a premium amount. The cost for the district heating is somewhere around 6 cents per kilowatt hours in Hamburg. Yes.
I'm jealous.
Yeah.
Mike, what was the most challenging aspect of this? I mean, I think like the district heating seems to be like that was like a nice freebie for you, but what was the most challenging aspect of the project for you all? In any of the areas or each of the areas?
Right. So I'd like to divert it to Amin. You'd like to answer?
Yeah. So I would speak first of all from the architectural point of view. We had technically how to make a design aesthetically pleasing, as well as be around with the numbers that are required for solar decathlon, especially that it's a net zero energy building. It was quite difficult to get that. We had a lot of variations to get to the AV ratio that we required for that. The type of materials we had to use, because we used from our partners, most of the materials were recyclable. So we wanted to get to the numbers that we had. Another thing was the affordability. Because we had to ensure the required rentable area to get the payback for that. So that was also another challenge. But yeah, those are in big lines, those are the major challenges we had so far. Yeah.
So a question I have is the emphasis on seniors. I know you're going 17% of the residents are seniors, but then you said you really allocated them to the third floor. What's the difference in the quality of their spaces versus the other units that you're establishing that they have to be regulated to the third floor or the bottom three floors? Bottom three floors. Right. Sorry.
So Neil would answer that question a bit more in detail.
Thank you so much for your question. So the difference between the residential quarters for the senior citizens versus the residential apartments for the, say, younger residents would be that the apartments for senior citizens would be equipped with a certain BMS system for emergencies. They would have a certain emergency call button at a particular height, which is actually lower than the average height for your reaching for your hand. For example, if the resident falls down, or there's an injury, it might just so happen that he or she is not able to get up. So the button is so close that he can hit or she can hit it on the wall at the button. The signal directly goes to the BMS room, which is manned on the ground floor by a BMS engineer 24/7. And once the signal actually reaches to that place, the person can immediately try contacting from where the signal actually came. If the person there is no reply, he will call the EMS. This is the main feature of one key feature. Additionally, of course, there would be some accessibility features that would also be integrated in these apartments by having wider doors. For example, in the sanitary rooms, there won't be any bathtubs because the access to these places would be a little tricky. So minor changes in terms of how the door widths would be wider for senior citizens, and the same. And in contrast, it would be for the younger residents. I hope this answers your question.
No, it does answer, but it leads to just a thought, because when you segregate people and place them in certain locations, you don't necessarily encourage mixing as much. And I agree with all of I love the way that you specialize those units. That makes the BMS system and its corporation, it makes a lot of sense. And I love that. But I wonder if, seniors love the younger folks because it helps make them feel younger. Once you pull them down into one location, maybe you've limited their interaction with their neighbors. And I think that could be something that could stretch a little bit more and stretch the goals there.
I would like to direct this exact question to my colleague Amin.
Absolutely.
So that's a very good question, actually. So I mentioned that all of our units, which are 18 exactly, spread across the entire floor area on the first three floors. We made sure that on each we have 5 circulation floors. So on each circulation floor we have 3 units. One is single family, one is larger family, and one is senior citizens.
And I do remember that about your circulation cores, and I thought that was a very interesting way to achieve your goals of the cross ventilation, and it's a very interesting way. I think the challenge that I see in industry-wise is you are building extra circulation because 5 cores means 5 different sets of elevators, 5 different sets of stairs and things of that sort. I think it's a very unique way to approach that. And I think that's a great way to stretch the architecture, but also a way to stretch to make a better unit. So I applaud that exploration.
Thank you.
You said you were going to use CLT for your balconies. So do you plan on using it? Are those cantilevering through the building, or were those add-ons to the building? And CLT as a exposed building unit is something that usually needs to be protected. So so I was a little concerned about I like to see CLT, but not necessarily on the outside of the building.
We will actually be using the cantilever, but the beams for the balcony would be deeper than the ones that would be inside naturally, because them being balconies. However, that being said, and as you pointed out, that as it's exposed outside, it needs some protection. So we will take care of making it weatherproof against snow, rain, and etc.
I guess in your modeling and in your detailing for that. I'm sorry. Were you about to jump in? Anybody else? Go for it. Sorry.
No, go ahead.
There's 7 minutes left.
Okay. In your modeling and your calculations, when you're talking about that cantilever for the CLT, did you consider, or was there, did you see any challenges with the thermal breaks that possibly need to be incorporated, or because it does feel like that then becomes a conduit straight into your building, how were you accommodating that?
So to answer that, yes, there would be thermal bridges. Once it's a cantilever, it is coming out from the wall and the slab. But at the same time, we took care of it by having insulation on the external side as well, and having an insulation on the internal side as well. We have plaster. We have 3 layers of CLT, and we have the insulation from outside and inside. That being said, the windows and the French windows, which would be used on the exterior side to access these balconies, would have enough U values / R values to take care of these thermal bridges.
So, and to stay on the CLT topic, I love the use of CLT. I actually tried to build Denver's first 13-story CLT building, and I got shut down by the fire marshal. And also, they wanted me to encapsulate all the CLT, which defeated the whole purpose of using it. So I'm curious on this project here in this jurisdiction. Are you allowed to leave the CLT pretty much exposed in all the units, or do you have some a percentage requirement that you have to encapsulate?
So the CLT is used in the structure and in the separation walls on the inside, in addition to the gypsum boards. On the outside, there is a solid clay brick cladding on the outside. So it's not exposed directly to the outside, apart from the balconies, as Mr. Michael mentioned there.
That's all right. I meant inside the units, and I need to go back and look at in the inside of the unit. Will the CLT material be inside the unit?
No, they will not be exposed.
Oh, okay. Is that a design choice, or was
that was a
requirement?
design choice? Yeah.
Okay, interesting. I'm just curious why.
because
Because
of,
appeal, a lot of projects, the appeal, in Australia, they've used it a lot, and in Europe, the appeal is to have the visual effect of the natural look of the wood. Not the whole unit, but a majority of the unit just kind of gives that warmth look.
we
That's
tried,
what we were trying to
so we tried to the different compositions of the interior walls. And the one that you went with is the one with the gypsum one is the one that got the numbers that we required. That was basically our reason to.
Also to actually add to that, the furniture that we intended to design on the inside, before, if you can see in the render, the tabletops and the main things were actually going to be of CLT. So we actually integrate that by giving the people the look of CLT. But if we expose the entire interior structural system to CLT, we thought that it was an architectural decision that we made, that we want to go ahead with not having everything completely exposed, but partially.
So it wasn't a code, it was not a code requirement.
No.
I have a question about your plaza. You've crafted it very carefully to have the maximum amount of solar access, it appears, from one of your diagrams. What type of activities do you have for your building occupants, especially the seniors, since that's one of your goals is to accommodate senior living? Yeah, that's a great image there.
So basically we have a children's playground. Okay, let me start from the beginning. So we have cafeterias and restaurants along the boardwalk on the south here, and that continues to the access on this side. We have on the little bit secluded area on the inside the senior recreational area. They would have special equipment for training, etc. As you can see on the outside. And we have also a children's playground on that side. And from this side, it's basically landscape design and recreational areas for the other users.
Done with questions, or we have 2.5 minutes left if you want to ask more, but we can conclude if that's it.
Well, I would like to hear from the two who haven't presented. What was your experience in the project? What was fun for you?
Hi, I'm Yutong. I mainly design for the space. I'm a landscape architect and also organize the regulation and norms part.
Cool, thank you.
Hello, I'm Fakhruddin and I'm financial analysis, and I try to calculate the cost calculation and payback period and all the financial parts of this project.
Great.
Thank you.
Cool.
I do see there's one online as well. Karina.
Yeah, we have three members online. There is Karina, she's Karina, Moin, and Fatma. Fatma has been a material and LCA expert. Moin has done the energy analysis and simulations, and Karina has helped with the durability analysis, and she's also an architect and also has helped with the whole project management part during the whole process. So that's the whole team.
Great. Good job.
Great job, guys.
Yeah.
Thank you very much.
All right, thank you. Give us 1 second to change over the slide.
Yeah.
Traditional.
Yeah, that was the shortest one. That's one that I caught. There's a couple other ones actually. It's very similar. Single one actually says that.
All right, next we have the Wentworth Institute of Technology. We're running a little early, a little ahead of the time, but is Wentworth here? Yes, no? Okay, we'll wait a few minutes. Wentworth, if you're online instead somehow.
About 12 minutes at the beginning.
Yeah, let's meet back here by 9:45. Wentworth, if you are online instead somehow, let us know.
I spent a year of my life and a lot of money trying to do it. And I had land lease as a partner to build it. With this Australian company, they were going to build it with us. And the fire marshal threw us out.
Welcome back, you guys. We're going to wait just maybe 2 more minutes until the time slot for Wentworth, but then we will resume shortly.
One of our professors is yeah.
Yeah. I think. Okay. You emailed the question. I saw it immediately. Okay. I was reviewing it. I'm not the sharpest tool. No. You emailed. Yeah. Is there a cheering squad? What just happened? Yeah, it was that. Yeah.
We got some fans.
Yeah. Cheering section.
I thought they got rid of the Zoom mobbing thing at the start of the pandemic.
Okay, welcome back, everybody. We have our second team, Wentworth Institute of Technology, and take it away.
Hello, everyone. We are heliocentric design from Wentworth, and this is our building Solarium, located in Boston, Massachusetts.
Hi, everyone. My name is Jordan.
And I'm Hannah.
I'm Robbie.
And I'm Ryan.
Looking at the sectional perspective, you can see 9 designated categories we'll be discussing throughout the presentation to create a whole building design.
So Solarium is located along one of Boston's major roadways, Huntington Avenue. Situated just a 15-minute subway ride from downtown, Solarium is surrounded by collegiate institutions, art museums, and world-renowned hospitals. Out of 15 major U.S. cities, Boston ranked 3rd lowest for green space density, so we plan to combat that.
Solarium is located in climate zone 6B, so meaning we have cold winters and hot, humid summers. Looking at the adaptive comfort chart, you can see that there's red peaks indicate places where it's uncomfortably hot. So Solarium plans to combat that with passive and active systems.
So Solarium's design goals are formulated to address issues that are prevalent in Boston. This includes achieving a net positive building, reclaiming nature through urban green space, facilitating community engagement, promoting a sustainable lifestyle, and providing housing equity.
With the imminent housing crisis in Boston, you can see only 400 units of affordable housing are available surrounding the site. So Solarium offers 50% affordable and 50% at market value. The cost is $48.8 million, but carbon and other environmental costs that accrue over the span of the lifetime, the life of the building is avoided by investing in net positive.
So the existing site for Solarium is home to Wentworth Institute of Technology Sweeney Athletic Field. Thus, demolition and redevelopment are fairly simple. Solarium's concept is derived from Boston's lack of a constant and strict urban grid, meaning there's a plethora of triangular sites and sharp angles in the area. And so we take those triangular patterns and further implement them into the building's design. Starting with Solarium's massing, it centers around a basic U shape, centered around surrounding site forces and the path of the sun, which aids us in achieving a net positive building. Next, we begin to slope the building up towards the back of the site, again maximizing the solar impact on Solarium. Then we begin to pull the facade back on each of the shared resident balconies, or on each of the slope forms to create shared resident balconies and slope roofs for rainwater collection and solar. And then lastly, with the integration of shading devices such as a wooden screen and canvas roofs, Solarium is able to utilize sunlight for energy, occupant experience, and landscape.
The commercial program consists of a variety of activities, including a cycling studio, art gallery, restaurant. The map indicates similar businesses that are surrounding the area that are inaccessible to the site. So what Solarium does to facilitate community engagement, we make these businesses closer to home, more accessible. Residential program, in order to create an equitable environment for residents, we include gym, gardens, and multiple lounge spaces for residents to use.
So Solarium's main building materials include light steel framing, wooden slats, glass, solar panels, canvas, and then metal panels. And all of these aid in the life cycle of the building and its integration with the site.
The structure consists of a CLT column and beam system supported by a concrete slab and steel reinforced footings. Active systems, Solarium prides itself on the systems that last the lifetime of the building, including a DOAS system for ventilation with radiant cooling pipes, geothermal heat pump, solar panels, and radiant floor for heating and chilled beams for cooling in commercial areas.
So all of Solarium's main building materials are cultivated within 286 miles of the site, under the 500-mile maximum radius as defined by LEED. All the residential units are prefabricated off-site to reduce construction time, waste, cost, and risk.
In order to reduce global warming impact, Solarium uses sustainable materials and practices that reduces carbon emissions by 101%, saving 117 trucks of ice per year. Working in juxtaposition, active and passive systems create sustainable net positive building. Cross ventilation, high thermal mass of roof, wall, and floor assemblies, and solar game all contribute to Solarium's success as a net positive building.
Solarium's landscape consists of a variety of sustainable gardens and terracing catered towards the community and residents. The southern facade utilizes a dense wooden screen for shading for the units, and then the northern facades are dedicated or have a dispersed wooden screen for ambient daylighting and aesthetics. Solarium's garden types include a community garden, children's garden, pollinator garden, Zen garden, and botanical garden. And each of these garden types help to fight the endangerment of native New England species. And then they also all help to combat Boston's low green space density. For each unit is equipped with energy efficient light bulbs, appliances, and thermostats, which can all be controlled through the Solarium Central app, which aims to achieve or promote a more sustainable lifestyle. And then with this app, you can also control cross ventilation vents to provide cooling during warmer months.
Utilizing sustainable materials like wood and mineral wool, Solarium is able to achieve a greater thermal mass. Looking at the green roof assembly, you can see plants are absorbed through the assembly, and the runoff goes to our rainwater harvesting system.
So Solarium's rainwater harvesting system is complete with a cascading gutter system that pools into a rainwater garden below. After these plants are nourished, the water is pulled into a tank where it is then filtered and then reused inside the building. And this can be used for residential and commercial program, which awards us 8 LEED points.
Solarium receives at least 300 lux for a minimum of 52% of the annual occupied hours, meeting LEED requirements, and shading devices help to keep annual glare hours under 10%, meeting LEED standards as well. Solarium utilizes design centered around the sun, on-site energy storage for solar panels, some of which is forwarded back to the grid, and the current solar panels offset negative 14.2 EUI off of the building.
Solarium's water usage is directly related back to the rainwater harvesting system. Storage tanks provide the capacity for Boston's average yearly rainfall, as well as graywater recycling. And Boston averages about 4 feet of rainfall per year. And so we are able to use that to offset the amount of water that we take from the city.
And finally, broken down into residential and commercial sectors, the residential EUI is negative 0.12 and the commercial EUI is negative 3.12, awarding 18 LEED points for Solarium. We achieved this net positive with on-site solar generation, passive and active systems.
So by achieving net positive design, reclaiming nature through green space, facilitating community engagement, promoting a sustainable lifestyle, and providing housing equity, Solarium is able to act as a beacon in multifamily housing and sustainability.
Thank you.
Thank you very much, and we will move on to juror questions.
Great job, guys. Thanks for coming to the presentation. Can you talk a little more about how you envision combining the CLT? Because I see a CLT structure and then I see volumetric modulars. How are those being combined together to form a building?
So do you mean like prefabricated units? in that sense.
Yeah, and maybe, sorry, if I'm confused, because I see on the presentation, I see a CLT structured building that's, and then I see volumetric finished apartment units. Do those get, did you envision those are sliding into the?
Yeah, so it would basically be the unit itself consisting of the materials creating the overall unit, and then they would basically be slotted in between like the column grid of the CLT structure on site that was built on site.
Interesting.
Yeah, so if you can see, all of our column grids are situated in between each of the units.
Okay.
So that way, all of the units can be kind of prefabricated offsite and put into the building on them.
And you guys have talked to the structural engineer and the jurisdiction and kind of gone down that road a bit to see if that is achievable to do that?
We've done our research. We looked at precedents that have done something similar to this.
Okay.
We are like I said, we're all architecture students.
Okay.
Engineering consultants were not involved, but we have done our research, and this is as far as we know it's possible.
Okay.
I will agree that it is possible, but I think where this could be strengthened is in your sections right now. You're drawing almost like a typical wall section where you would see the post and beam, and then it kind of blurs where the floor slab is or where the ceiling is. I think when you start talking about modular, you got to think of that unit by itself and how that unit slides in. For instance, is the floor a part of the modular system, or is the floor a part of what is set? Because there are multiple ways to skin that cat. And then also, like, how is the exterior? Is the exterior part of the module? Or is the exterior something that's coming in after it? I think it's pretty clear that the wood slats would come in after it.
Yeah.
But I think there is some investigation and thought, because there are efficiencies in bringing that module in with the exterior as a part of the module. But then there's the other challenge, because with Boston and its climate, I know right now you were showing it up to the corridor. You may need to take it all the way to the other side of the corridor so you can seal that as well, possibly, because just the effectiveness of the prefab is getting the most out of it. And I think looking at that a little bit more is something that this could look into.
Thank you.
It wasn't clear until you described it just now how you were managing the slats. And so and now I see it clear. So I appreciate that explanation. The south being much more densely packed, and then the north more dispersed to allow that. And that's just I guess one choice. Wood is not necessarily a very durable material in an environment like that. So what was the sort of the thought process behind wood? Or like, were you just planning a treated wood product, or did you look at other things like what if we made it out of metal panel or brake metal or something like that?
One of the things that we were looking at, it would definitely be treated, but one of the things that we were thinking about material wise was that because this was an existing site that was pretty open, and then we're kind of coming in and developing on top of that, we were really looking at material studies of things that, since this is very centered around like our green spaces and kind of like the outdoor spaces, we wanted materials that would be reflective of those spaces. So the wooden slat system was mostly also with its life cycle, but to also kind of integrate it with the site.
More of a natural, sort of a forest.
Like all the green that would bring it back to Boston.
We envisioned this like later in the future having like some vines and vegetation on the road and side. So give it back to that.
Yeah. Interesting.
Yeah. And I guess to that, and I applaud, and I'm sorry, I know you're about to lean in and go for it. But to applaud where your floor plan and your shaping of your building, I think it's an interesting approach as far as getting to achieve the green spaces, as well as with the rainwater and things of that sort. I think what you'll find is you're a little bit challenged on your floor plan. With the two interior stairs right now, you have a dead end corridor issue. Because you have almost 175 feet before that stair in that middle court. And so that's the challenge of the shape and the form that you've created, which again, you are students and that's not always at the top of the thought, but that's something that you'll have to think about is for that
So
egress.
we actually, we did combat that. So on the lower 2 to 3 levels, there is an egress stair on the bottom, on each side of the staircase. And then the corridors, exit out onto the community balconies towards the end. So we did check for egress requirements to make sure it didn't exceed the 2 egress paths.
Yeah. I guess I need to double check that plan because when I was looking at some of the longer upper floors, it was still looking like it was close to 175, 125 feet. I think it's like your fifth floor plan. But even moving beyond that is the 50% affordable and 50% market. It's a similar question that I was thinking about is how do you distinguish those two? Is that something that came in your cost metric that helped drive the value of this building? What's the difference between the affordable and the market rate units?
For us, I think the kind of idea behind it was that there weren't any distinguishable factors between those because one of our design goals was kind of providing housing equity within Solarium. So like all of the residential program, all of the community program, that's all accessible to everyone in the building. So that was something that was really important to us when we were designing this.
It's a very good answer. It's just a question of, do the numbers work when you do that?
Did you explore any tax credits in your financing to have a better return on your investment? Because half of it is affordable.
I mean, with minimal research in that area, I'm assuming there are like grants and multiple things that are able to help us with the cost of the building. I think as far as thinking of how it would be paid for investors and things like that, and people that are really invested in net positive building, especially with Boston's goal of 2030. So I think that area.
You'd be looking for private investors in lieu of a government assistance, like a tax credit program.
Definitely.
Yeah,
something
that would be
to look into, yeah.
And then what kind of AMIs are you when I say AMI, average median income, when you're shooting for 50% affordable and 50% market, have you guys thought about which average median income, what percentage of AMI that represents when you're?
Not an average, but there are similar buildings surrounding the area, apartment units that have a cap of like how much of that you make. And then I think it's something similar we were thinking to that, where you have to be in a certain pay range in order to be considered for affordable housing.
I believe that in Boston, it's around, if you make under, it's like 65 to 70,000 a year, you qualify for affordable housing. So I think that would be kind of what this is catered towards.
Maybe a question for the jurors here. I've only conceptualized a CLT building. I noticed they have radiant floors in their building as well. Are those compatible systems? Like,
You'd have to incorporate a topping.
okay, I think it had a 3 or 4 inch concrete topping.
Yeah.
Okay.
Yeah. I was looking at your like green roof assembly, and for some reason I got fixated on the gutter system. with the water cascading down and all these, just like it could see as it comes down the side of the building, it would sort of collect, and you would have a pretty major waterfall by the time you got to the end. So what do you plan on sort of collecting and interrupting and slowing down that flow as it goes down the building, and how are you managing that?
Yeah, so a lot of like, as the water cascades down, there's also the green roofs with the solar panels as well.
Okay.
So those will be compensating for
So
some of that water.
the solar panels are incorporated with the green.
Yes.
Yeah,
Okay.
they sit on top of the green roof. So as the water is traveling down from the gutter, the overflow over the gutter would then travel through into the soil.
Okay.
That would kind of slow the process of going down the slope.
Okay.
To get to the next gutter system to eventually bring it down to the rainwater garden at the ground floor level.
And the other important thing to note too, this is just one of them, but since there's 2 sloping forms on each side of Solarium, there's 2 of these systems.
Right.
So yeah.
Right. Yeah. And Can you go to the, your app slide, your resident app? Actually, pretty excited about that. I've actually spent quite a bit of money in that. If you just give me, just give me a background. Are you guys planning to white label an existing platform that you're using? Or just walk me through kind of your thinking on the app and how it's being developed. And
so basically the whole process behind the app would be going basically to kind of create like a community within the entire solarium. So
and are you guys designing it yourself?
So basically,
Really?
so
Okay.
when we started the project in January, if we did like begin this project like a while past, like a year past, we would have actually developed the app to actually
very
make
cool.
it created. But this is kind of like a conceptual mock-up of
So it's like an MVP. You guys have actually put that together?
Yeah. So basically with the app, we wanted to create like basically a hub to use within all the residents, but also people like within the community around who could download the app and be able to utilize it to book, to see like stuff in commercial spaces, to book a class in the cycling studio, see what's available in the farmer's market, be able to order food on the sub shop. Sorry. And so basically so within like the top left, that's mainly for the resident people that would live there.
Yeah.
So they'd be able to check the air quality in their unit, control the different radiant heating zones within the unit, see the humidity levels, and then like Ryan said previously, see the be able to control and open the cross ventilation vents in the section that we showed before. And then the activity feed is kind of more so like almost like a Facebook type thing where people in the community can post about solarium, talk about the different garden spaces that they're involved in, their favorite ones, just basically to connect and get collaboration and interaction between the people within the community overall. And then some of the notifications we listed, like if you left on a light and you're out of your apartment, you can be able to, it'll pop up and say, hey, you left your light on, you can shut it off if you would like to save energy. And then just typical like new art available in the art gallery, come check it out. Just different things like that, just to build the overall sense of community within Solarium and the residents around the whole community.
What I appreciate about that is the awareness, incorporating the awareness of the sustainable features in the apartment, because it's going to be the user who creates the loads. And truth be told, it's kind of out of the architect, the developer's hands to really more or less control it when you're talking about market rate. And I appreciate how you're incorporating that. And I also appreciate where this building is and what your design is taking an attention to detail to creating an environment and spaces for the users. And you're not discriminating just because of 50% affordability. That's another strong point that I really appreciate with this project. And so I think that's something that we can all do a bit more, because everyone deserves that equitable housing, which is one of your goals. Yeah.
So I'm gonna get back into the wall assemblies after that inspirational. Still good. Now let's talk about how we build this thing. So behind your wood slats, what do you envision that assembly being back there? Like, I could see from the drawing, you've got your framed wall and your exterior insulation, and your like where are your control layers, and how does all that integrate, like roof to wall, and what do you envision there?
So the system is the materials that we mentioned earlier. It would be supported by like a light steel framing system, which would attach the mullions on the building. And they're actually lined up with each of the mullions as well.
So is the wood slat intended to be the cladding part, and then you've just got a huge rain screen cavity behind it, or is there some other cladding on the face of the wall sort of behind that?
Oh, those would be metal panels.
Yeah, so
metal
panels
metal
is
behind.
the actual facade of like the unit side,
All right.
and then the wood slats act as like a shading screen, rain screen.
Yeah, there's a lot of roofs over living spaces, which are always worrisome. So those are.
I mean, speaking of how it's built, why the single loaded corridor? You have this very glazed single loaded corridor on the, what is this, the north side of the building? What's the thought of that?
Sorry, but
Oh, that's it.
I have to ask them after today is all done and maybe tomorrow. Thank you very much.
Cool. Thanks.
Wentworth, she wants you back up here. All right, so we're gonna take a quick break. We're gonna come back at 10:25.
Zoe. Who's after the break?
Who's that?
Yeah, I knew really well. He went to UC with us.
Oh, really? Cool.
So yeah, I saw you were from Seattle. I was like, oh,
Yeah,
let's go
no,
to
Steve,
Steve.
yeah. It's been really fantastic. Yeah. Oh, so let's meet.
Okay, cool.
We'll be up in two.
Yeah, cool. We'll see you soon. Yeah, thanks. See ya.
Yes.
I'm warm, y'all. I'm warming up.
Yeah. Good. Man, I know you were giving us a sermon.
I'm warming up. Yeah. I'm working on my sandwich approach, by the way. I'm working on that sandwich approach. Yeah.
Yeah, modular folks now. So we've got
Factory, I think Factory OS.
yeah, right, yeah. Yeah.
The old blue home plan.
So there's, I mean, we're 300 people in 9 offices and we've got our fingers kind of everywhere. Yeah. So,
9 offices.
in Canada and the United States. Yeah. It's like I started the Seattle office 18 years ago. And then Portland office started at the same time, Portland, Oregon.
And then you obviously you're set the DC office one.
Yeah, so now
All right, we've got people filing in.
Well, I think
And
we're at lunch.
Okay. Yeah, definitely. Yeah, for sure.
so we're going to start back up again. We've got the University of Illinois, Urbana-Champaign up next. And then we'll have the University of Cincinnati and then the Cooper Union. And that will be followed by lunch. So without further ado, University of Illinois.
Hello, and thank you for joining us here today. We're the Illinois Solar Decathlon team at the University of Illinois Urbana-Champaign. We're a team comprised of 23 graduate and undergraduate students with backgrounds in various engineering and architectural programs. For our project, we have paired with our university's facilities and services team to create a redesign of the former Orchard Downs student and faculty housing. For our new design, Urbana, we'll revamp the community and we aim to bridge the gap between the city of Urbana and the University of Illinois. We'll be introducing commercial spaces, which will provide a tax revenue to the city of Urbana. And then our new and improved residential and community spaces will provide a safe and healthy environment for our growing families and residents. Located in Urbana, Illinois, in Climate Zone 5A, our site sees predominantly sunny days for 9 months out of the year. However, we do have a great variance in climate. This climate variance means that the most effective way for us to mitigate our environmental impact is to first mitigate our heating and cooling loads.
Our market analysis strategy first included to perform site analysis to understand the demographics of age and race our project is going to market towards. Secondly, we performed intensive research to calculate the median income of the Urbana people. So in order to make our residential rates affordable. Thirdly, we performed cost analysis to understand, to calculate the construction cost, which came around to be $18 million and a total construction time to be 15 months. The total construction cost includes 40 residential units and 7 commercial units. The residential units include studio, 2-bedroom and 3-bedroom apartments, while the 7 commercial units include grocery stores, daycare centers, and restaurants
restaurants and cafes. Jumping onto the consumer perspective, we have comparable rent rates to the existing projects in Ashton Woods, Orchard Downs, and University housing. In a nutshell, Urbana project offers an affordable solution for residents, commercial tenants, and satisfies the needs of the community.
As mentioned before, our site is in Orchard Downs, Illinois, and it comprises of 250 feet by 45 feet. The most architectural economic decision that we have taken is to have one multifunctional building instead of segregating spaces. So the segregation of spaces in our design is the public spaces are on the first floor and the rest floors are residential. The 4 X factors of our design that drives the architectural aspect of the design is passive strategy, nanobiome building skin, preservation, and net positive approach. To maximize the efficiency, we considered natural ventilation and solar orientation, and we considered east and west access to be the most optimized one. Nanobiome building skin is a newer technology which is highly sustainable in its approach, which inhales, the skin inhales carbon dioxide and exhales oxygen, which is exactly the opposite of what humans do. Preservation, we try to retain the natural landscape around the site, and to give a fun fact, we did not even cut one single tree in our site. Net positive approach, we generated excess electricity and energy in a way that we were providing stronger financial performance to the site. This is a section cut which shows the segregation of commercial and residential units. To provide a cohesive environment, we incorporated multifamily and student living together. The wall section here shows how the indoor quality of the spaces is improved by the nanobiome building skin. This elevation is a proof of our strategies being working out. The solar orientation here is to the true south, which is to optimize the sun. Next. As a result, the energy production was 1.5 times of what we expected the consumption to be, and the green spaces provided sustainable natural ecosystem around the site.
So now I'll be talking about our energy analysis, which is done using the Open Studio software. By inputting the details listed on the left, we're able to have an actual energy use intensity of 18.43 kilobTUs per feet squared. This pretty much summed to around 830,000 kilobTUs annually, with our largest load being heat. And next, going into our PV array, which is designed using the Helioscope software. By inputting the details listed, we're able to design our 2 main arrays, one on top of our roof and the other one on top of our parking garage. And if you look at the monthly production and consumption chart, you'll see that we'll mainly be focusing on selling our electricity in the summer. But because of the much colder and more cloudier winters, we'll have to rely on the University of Illinois solar farm to meet demand in the winter. So in conclusion, our solar farm was able to have an annual production of 923,000 kilobTUs, which is well over our annual consumption of 830,000. And on the figure on the right, you can see our electrical diagram that shows our energy flow from our PV panels to our appliances, the grid, and the battery. Now going into integrated performance, this is a schematic of our parking garage. It is a solar surface parking that covers our cars and protects them while allowing them to have a platform for solar cells on top.
As a schematic of our building skin, we have used 2 technologies. One was Moss wall and the other is nanobiome building skin. This also incorporates of using water reuse and provides a healthy environment. In terms of structures, we have used mass timber, radiated cement concrete, and fiberglass insulation, which is highly sustainable in its approach. And the construction is integrated in a way that we have achieved cost to durability ratio. And the construction is also in a rectangular grid pattern, which reduces the harmful effects on the environment.
Rainwater and gray water reclamation systems were implemented into our water design. These 2 systems meet the irrigation requirements of the biowall. The efficiency of the overall water design is also increased, 60% more efficient than conventional designs. Heat recovery ventilators include a cloud-based control system, which allow for the simultaneous control of each individual HRV unit by building managers, in addition to mini split systems, which allow for the control of the residents for their own climate needs. Our HRVs can also recover up to 93% of heat. They use MERV 13 filters, which reduce the risk of the spread of disease, in addition to decreasing discomfort from residents with allergies. We also use multiple sensors, 2 light sensors, 1 thermostat, in addition to an environmental sensor, which measures the CO2 levels in our buildings. Our indoor environmental quality is achieved through using low emittance materials in addition to the previously mentioned equipment. We also have sustainably sourced furniture, and we try to maintain a LEED certification through a humidity level of 65% or less using the HRV and mini split controls.
In conclusion, our building aims to achieve net zero energy, to create a healthy and safe environment for our community and our residents, and to also reduce our environmental impact. On behalf of the Illinois Solar Decathlon team and the University of Illinois, we thank our jurors, listeners, and corporate sponsors.
Thank you very much, University of Illinois. So now we'll move on to juror questions. Just a note, these questions have been great and they've sometimes been very hard, and that's kind of what we're here for. We're learning. I'm learning as we're getting these questions, so keep them coming. Thank you.
I have a question about the use of your building, in particular the placement within its context. It appeared to my eyes that your mixed-use building is in a single-family neighborhood. Like, just looking at that picture, for instance, looks like it's on the edge of campus, and I'm wondering how you justify the ground floor commercial use in what appears to be a residential context.
Right. So the main concept behind including our commercial spaces is that traditionally this area is a residential area for our students and our faculty. And originally the nearest grocer or any kind of commercial space was 2.3 miles away. And so what we proposed to the university is our carbon footprint. And with students, a lot of them in this neighborhood don't have cars, or the buses take an hour plus to get to any kind of commercial space. And so what we're doing is we're kind of isolating this commercial space away from the rest of the residency. So if you look up here, so this is the majority of our residencies here. And so we've kind of isolated onto the corner of the campus, which gives us ample space between other residents and families, while also being able to provide those commercial necessary needs for our community and reducing that carbon footprint and allowing students to be able to access commercial spaces without the need of car or bus.
You guys make sure that when you're answering questions, you're at the mic. Thank you.
There's one quick thing I wanted to add. When we performed the site analysis, we found out that a lot of people in the neighborhood wanted a grocery store or daycare center. There were a lot of single family living there. So the need of the community was to include a commercial space to make everything easy for the community.
Can you talk a little bit about your solar array, the rooftop solar array? What sort of payback period are you envisioning for that system there? You guys run some calculations on that?
That is a
as in how many years would it take to pay back the investment of that solar array? Do you guys talk through that?
So we have a positive net approach. So we are generating energy, but our solution was to implement a Tesla battery, because as you know, we are having a negative basically a positive consumption. So our solution was to implement a battery and use it when we need it, basically.
Okay. And I think you mentioned in your presentation that you were looking for the remaining of the solar generation to tie into a local solar farm.
Right.
Did I understand that correctly?
Yeah. So if you look here, we do produce more energy than we consume on a yearly basis. Okay. But due to our great climate variance, we have this issue where in the summer we have great sun, and it's the same during our fall and our spring months. However, during the winter we see predominantly cloudy days, and so with this deficit that we see in the wintertime, there's a solar farm located in Champaign, Illinois, which is just less than 5 miles off site. Okay. And so we would connect to that during winter months. Okay. to make up for our demand. Where in summer months we're making excess, we might sell back to the grid, or even account for additional construction on the site, as there are more plots that are empty. And so any access that we might make during the summer months as well could be routed into our new buildings.
Got it. And your solar array, I think you had a slide where you should also show the parking area. I believe, I think it was your last slide. So showing all the buildings, the aerial that you have all the buildings. Go back to the neighborhood where. Early on. Yes, that one. So your solar array for your site is obviously a combination of what's on your roof and also the carport there?
Right. So I
Okay.
think our intro slide might help you a little bit more on that one, so you can kind of see it. Yeah, so you can see in the far corner, this is reflected from the other one, but it's on top of the parking garage that we have located on site as well. So it's, yes, it's a combination of roof and then our parking garage.
And with batteries at your site, you still feel like you need to connect to that local solar farm? You don't think that, I don't know the climate there. There's not enough sunlight. There's not enough sunlight and battery capacity to actually keep what you need in those.
So through
those darker
financial
days.
analysis, we thought it isn't financially viable to sell it to Embrand, which is a huge supplier for electricity. They provide us a rate of 0.09 kilowatt per kilowatt hours.
Okay.
So then it's much more beneficial for us to have a storage system and use it rather than selling it at a lower price, basically.
All right, thank you.
And like you asked too, we do have the capacity to store enough power, but it's more in the case of this happens for like the durability of our building. So it's more of the case on maybe like climate crisis, where if we have some kind of outage or there's like a down in our neighborhood, we can connect to the solar grid, which isn't connected to anything except for other residential buildings. And so that might just be our like more of an emergency backup, so that we can provide power to our residents during all times.
And one more thing that I would like to add is that we talked about the climate variance, and in the winter, being in Illinois, it gets really cold there. So we haven't increased the energy demand because of heating. So that's why we really need to rely on like another source for meeting our demand.
All right. Thank you.
Could you speak to the, I'm more interested in like wall assemblies and roof assemblies and things like, so the nanobiome thing is really interesting. How, what was the inspiration for that, or what was the choice for the select? Why did you choose that? And then the wall behind that, I assume, is made up of different layers, and what are those layers?
Thank you for your question. We did precedence on Bosco Vertical in Spain, and then that's how we derived this technology, which is highly advanced in terms of sustainability. This is a living wall which does not require a lot of maintenance. So the water reuse that we're talking about, which we have as a rainwater harvesting on our commercial rooftop, we would be using those, and they would channelize water to these panels. So as you see in the diagram to the very right, you see the wall, the green surface that you have does not require maintenance, and it changes season to season.
Okay.
And it, as I mentioned before, it inhales carbon dioxide, which is the opposite, which gives a healthy environment. It is not only placed on the dead walls, but also to the walls that are near our windows, so that the indoor air quality index increases and you get a really good environment around the site. The other thing is the orientation. It was really important for us to consider the orientation where we place the most wall as well as the nanobiome. So most wall is oriented towards the north so that it receives direct diffuse light, and whereas the other three facade has the nanobiome building skin, which is closer to the water reuse channel, and then that's how it is channelized.
If I may make an additional comment, with our proximity to farm sites around during harvesting months and during planting months, there's a great upturn of dust within our air quality environment. And so part of this nanobiome skin is is addressing that fact that we're going to have a lot of dust particles and dirt particles that are coming in the air very close to our residencies. And so with small children and families that will be in the area, it's of the utmost importance that we create a really healthy environment for them, as that was also one of the initial issues that they mentioned in our site survey. So that was something that we wanted to address right off the bat, and this helped us to do so.
I'm going to ask a couple of questions in a series. Can you help confirm to me what the user is? It's multifamily, but it's really student living. Is it meant to be like for university housing where you can buy into? How does that work?
Right. So this is actually, it's a very specific community within Urbana, Illinois. So Orchard Downs has historically served for student housing as well as families and faculty. So this is a little bit farther outside of campus. It's next to our arboretum, so it provides a bigger and more spacious environment that's healthier for our families. And so that's what we've been targeting our main residential spaces towards. And then directly outside of the former Orchard Downs are also residential spaces for just our local Urbana residents and then additional students. And so our commercial spaces would also be available to those residents. And so it's kind of a mixture between, as I mentioned before, like bridging the gap between the city of Urbana and the University of Illinois. So this is kind of a mixed community space that should serve for everybody.
So it should serve for everyone. And is that, if we go back to your unit mix, I think you were, what was it? How many studios versus 2 bedrooms and 3 bedrooms? I noticed you skipped 1 bedrooms in that mix.
So we have 20 studios, 10 2 bedrooms, and 10 3-bedroom apartments.
Right. And so how did you get to that mix? Why is it so heavy on studios?
Because a lot of the people that we so what we did was we knocked on people's door. There are multiple people living around that area, and a lot of them were postdoc students. They were alone here, and sometimes they're trying to extend their families and bringing them, but in like the first couple of years they're living alone. So we wanted to target those people first, and then as time progresses they can move into bigger spaces.
Okay. And so then if that is, I'm still a little bit blurry on if this is like, if it's more like the expanded student type, like I know I'm postgraduate or like the upperclassmen, but I want to be off campus, but not really on campus. Or if this is like the family, like it can be a blurry mix. I'm still a little bit hazy on that.
Yeah, I guess that's one of the issues that has been in Orchard Downs itself, is that it has always been hazy. So it is generally our graduate students and our postdoc students, but what comes with that is married students and students with families. And so generally that is what we're seeing is graduate and postdoc students that will be coming from overseas. And so first they might come to the studios, get acclimated to the university. And so that's what we're seeing in our studios, but then they might have family that they bring over. And so that's where we get the addition of our 2 bedrooms and our 3 bedrooms. And so generally it is postdoc graduate students with growing families.
Okay. I appreciate the ambitious nature of this project where you're trying to provide the commercial or at least a commercial offering in a single family neighborhood, and the mix that you're kind of proposed there. How is that established in the architecture? How does that fit in with the community? Because I think to Alexander's point, with it being a single family, how did you kind of address the streetscape? How did you address the neighborhood? Because I think that's probably just as important as the next in the context of this lot in this space.
So as I mentioned before, we first had a intensive research of the site. We visited site multiple times to see what are the close proximity of the commercial units. And then we came into a conclusion that there were no pharmaceuticals or grocery stores nearby. So, and then if we have such a intensive site and we don't have commercial units close by, then architecturally we are lacking there. So we thought of incorporating commercial and residential together so that the people who would reside in our spaces won't have to travel long distances to get basic necessities of their life. So that's how we architecturally designed the commercial spaces to the ground floor and segregating the public and private so that they are not together, and then there's some there is social interaction, but there is a difference between the accessibility of both the spaces. So that's how we've addressed the issue architecturally. And the site, as I mentioned, it is 250 by 45 feet wide. So we offsetted our residential to 200 by 45 so that we create a communal space between the commercial and the residential spaces.
And to another comment about that is you can see in our first floor diagram that there's actually there's walkways in between our commercial spaces. And so this allows for us to connect with our green spaces that you can kind of see in these diagrams. There's green spaces on the backside of our building. And so residents can rotate around our commercial spaces, and so they don't have to directly enter those. They can go through the building and directly into our green spaces. And so that's something that our families might do more, is access some of the parks and the arboretums that are located behind our building.
And in addition to that, having such commercial spaces would also encourage neighborhood cohesiveness, which was one of the issues that we saw lacking in our site. So if we have commercial spaces, people would come to our site more to buy things, and then we would have more footfall in our site that way too.
Just moving back to your studios and
Thank you very much.
Thank you very much. Next up, we will have the University of Cincinnati, but we have a couple minutes before that. Jurors, do you need a couple minutes to finish your scoring, or can I ask you a couple questions while we fill time here? It looks like you're still working for a moment, so I'll give you a minute.
Sorry.
Is the University of Cincinnati here, just so we know? Yes, you're here. Okay. We can do your check here, but it's not quite time, but we can do your check.
Great. Yep. Great.
I'm still clearly on East Coast time. Oh, I feel like it's time for lunch, right?
You're welcome to rotate yourselves.
I won't ever get used to 2 hours.
After 5 minutes, 2 minutes, and then here's the time's up. I think you're here when I'm saying that too. And what else were we gonna remind them of? There's one like
2 hours maintenance of the question and remember to step up to the
Yeah,
right.
there's like this altitude thing. Does your body just get used to it?
It takes a little bit. It takes a little bit. Yeah, you just got it yesterday.
Yeah, because I felt it last night, like when I was sleeping.
Yeah,
I was
that's
like,
perfect.
oh, this is.
And you don't have to be like right in front of it.
Yes.
I feel
In
like-
work out.
Because I feel like I'm overhydrating right now, but I feel like I'm right on par with hydration.
Yeah, you know.
There's no such thing as overhydrating.
How long you been living here now? You raised here?
No, it's really about
Oh, that's home.
Yeah. Some native, so.
Yeah, he's practically a native at 18.
I think it goes, huh?
Good.
Good.
Oh, we should totally do that.
Good.
Yeah.
Oh, no.
Oh, and that's.
It's tough. How old is yours?
This is 13.
Okay.
So my two girls are
Okay.
Great. Thank you.
She was just like,
Wasn't happening. I'm stealing that one. My youngest, he's turning 2 in May. So,
there you.
yeah, he's his favorite word is hug.
Yeah.
Nice, that was fine. Early. Takes a little bit of the nerves off, just to
I'm
be
very
standing up
patient.
here. Okay, yeah, just relaxing a little bit.
How much time do we have?
What did you want time for?
You said you were gonna ask us questions. I was curious.
I have here, maybe we'll fit in one question
One
here.
question.
So for each of you. One question for each of you to answer. Why is it that you participate in Solar Decathlon?
Ooh.
We'll start with Bryce and then go down the line.
Yeah, because selfishly, I learn more. I learn more feeling than I give. And, so it's great. It's always great to come here and see what you guys are working on and just learn a lot.
I would agree. Just the opportunity to stretch my own imagination. In practice, I think you're constrained with reality, and not that you guys are off the rails or anything, but it's just refreshing to have different approaches to the same problem that we're all trying to solve and to work on.
Yeah, like let's build on. Those are 2 great starting points because it's definitely those 2. And then to add to that, I tried to make it a personal philosophy never to say no to students. And it's the learning and it's the growth that I learn from you, you learn from me, and whatever experience that they may say I have, who knows where those credentials came from. Somebody's going to find me out sooner or later, but seriously, our profession doesn't grow if we don't reach to each other and continue to build on that. And so whatever I can offer is whatever I will extend out there with no reservation. So I think this is also, without a doubt, one of the most important programs because you are pushing us to the limits of carbon neutrality, net zero, and the things that are important for our environment. So,
Yeah, I echo all of those things. And the opportunity for you to design a project from the ground up is before you're actually out in the real world having to really defend yourselves in front of funders is a whole, that's an important part of this. The lessons that you learn through this process will stay with you throughout your career, and you'll be the better for it, and we're all the better for participating.
Those are some great answers. Thank you. And we have it on record. So now Solar Decathlon, all of your quotes. You're welcome. All right. So now we'll move on to the University of Cincinnati's presentation.
Thank you.
Welcome all. We are excited to introduce our plan for an affordable senior housing complex near downtown Cincinnati, Ohio. We are a team from the University of Cincinnati consisting of 5 architectural engineers and our faculty lead, Dr. Webb. In the Over-the-Rhine neighborhood near downtown, there has been recent luxury development leading to an increase in the cost of living. The average person here spends 40% of their income on rent, and there has been a 54% increase in seniors who are renting. Cincinnatians also pay a high percentage of their income towards the energy bill. Seniors are often on a fixed income, so creating an affordable, energy-efficient place to live allows seniors to stay in this community.
Our site is located in Over the Rhine, a vibrant urban area with restaurants, shops, parks, and murals throughout. It is located 1 block from Finley Market, a popular open-air market. The nearby streetcar gives seniors access to the neighborhood and downtown. The senior center is also within walking distance of our site. Finley Commons will integrate seniors into the heart of an exciting neighborhood.
Our 4 guiding principles were building as a neighborhood, aging in place, energy efficiency, and a resilient design. Our goal is to create a strong sense of community among the residents and to connect them with the surrounding neighborhood. Finley Commons is a 50,000 square foot multifamily building with 45 senior affordable housing units and a public library branch. The building also features 2 dedicated outdoor courtyards and shared residential spaces.
Our building's massing creates exterior spaces to engage the public and connect residents to the outdoors in an urban environment. The building maximizes its footprint while dividing the site into separate public and private courtyards. The public courtyard is outside the library and invites the neighborhood in from Finley Market. They can listen to concerts, attend events, or sit outside the library and read. Private courtyard lets residents spend time with one another. Whether cooking on the grill, walking the reflexology path, or practicing urban gardening and raised planters, seniors can enjoy the outdoors. The first floor program consists of both shared resident space and the public library. The library and senior housing are a powerful multi-use pairing. The seniors have easy access to library services such as technology education. This new branch will let local vendors from Finley Market teach the community about their craft. There are also stacks of books catered towards agriculture and food. In the residential part of the first floor, there's a shared kitchen to promote community through food and cooking. Each floor has 15 units and a centrally located hub space. The hub space has a lounge and shared laundry room, which encourages residents to interact with one another.
Finley Commons serves the needs of its residents as they are aging by promoting connectivity, mobility, and independence. The apartments have been designed so that the occupants are able to remain independent for as long as possible. They are 600 square foot single bedroom units with an open kitchen and living room layout. All units are designed with walker users primarily in mind, and there is 1 unit per floor dedicated specifically to wheelchair users. Particularly in the kitchen, this is highlighted by keeping mobility in mind. Some highlights include appliance selections like the oven and fridge that reduce bending down or reaching up, and the deep toe kicks and lower cabinetry features are adaptable to fit the needs of the resident. All appliances are Energy Solar certified and cut down the electricity and the water consumption.
To reduce the energy burden felt by our residents, we implemented the following energy efficiency measures. Cincinnati has a mixed humid climate, meaning our building is heating dominated, but still has a need for cooling and moisture control.
Our baseline energy model was set up using ASHRAE Appendix G for a fully electric building. Using a combination of passive strategies, efficiencies, and a low energy HVAC system equated to a 59% reduction in EUI. The addition of solar means that our building truly is net positive.
Our building is designed with a tight envelope providing a barrier against the exterior air, moisture, and thermal properties of the climate. The structure consists of advanced wood framing with LVL beams and continuous insulation that give the roof an R value of 42, wall an R value of 35, and foundation an R value of 17.
The comfort and environmental control is achieved through the use of a 4-pipe active chill beam system. The system works by using a radiant coil to transfer heat into induced room air while supplying fresh outdoor air at all times. The system can operate great in both heating and cooling modes and is a great choice because it is highly efficient, thermally comfortable, and creates a healthy living environment.
Chilled beams are supplied with water from a roof-mounted air source heat pump with heat recovery. This system is able to produce both heating and chilled water and has a simultaneous COP of 9.86. A heat pump water heater with storage tank is used to reduce energy and the added ability to produce domestic hot water during off-peak hours. These systems are replicable on an urban site and in a large variety of climates. Our site keeps in mind grid interaction, carbon reduction, and the changing climate. Solar production is done with 2 separate arrays. The first is roof mounted on our building, and the second is installed in the county-owned parking garage across the street. This takes underutilized space and generates clean, renewable energy. Our design decreases stress in the electric grid through a combination of energy efficiency, solar generation, and battery storage. This plot shows the daily demand profile for our final design of purple compared to the baseline of blue. This reduces the demand on peak power generation, which can be carbon intensive.
Cincinnati has a combined stormwater and sewage system that often becomes overwhelmed following periods of intense rainfall. Water and human waste can back up out of storm drains, leading to health hazards. Severe storms are expected to increase due to climate change. Our building responds by collecting rainwater through roof drains and storage tanks in the courtyard areas. The tanks can then provide water for on-site plants and agriculture, decreasing the reliance on the city's domestic water system.
Our design reduces carbon emissions at each stage, including production, use, and end of life. To reduce embodied emissions, we focused on the production stage. The graph in the middle compares our building to a typical multifamily building. We use organic insulation, minimized concrete, selected wooden materials with low embodied energy, leading to a 36% reduction in carbon. In the use stage, we reduced operational carbon through an efficient mechanical system and on-site renewables. In the recovery stage, we increased carbon storage through the selection of organic materials. Our final design encompasses a three-tier approach. At the basis of our design, we focus on constructing the building to respond to our specific site and climate. Continuous insulation plays an integral role in making our building thermally comfortable. Shading devices and double pane windows allow for solar gain in the winter, but decrease conductive and radiant heat transfer in the summer. After creating a durable base, we focus on implementing passive strategies. I want to highlight the addition of shading above each window. These shades allow sunlight into the space while reducing intensity and glare. The shading on the first level also acts as a light shelf to allow indirect sunlight to penetrate deep into the space. Each residential window also has a dry contact switch that stops the flow of chilled water to the beams to reduce the likelihood of condensation and allow for free conditioning through the operable windows. In our final phase of design, we introduced mechanical equipment to comfortably cool and heat the space. Looking at our design, we can see how all the elements come together to create a comfortable, energy-efficient senior home.
Aligning with the rent price suggested by our industry partners, we will charge $768 in rent to our residents. Our seniors are the parents, grandparents, aunts, and uncles of the world, and as a society, we should care for them like they have for us. With more disposable income, seniors at Finley Commons can experience the excitement of living in our city and spend more time doing the things that they love. Thank you all for your time, and thanks to our design partners.
Thank you very much. We will now begin our question and answer period.
So I guess I'll lead off this time. You're good. So I don't think when I read in your report, you in your written report, you had talked about doing solar on a county-owned parking lot.
Yeah.
Can you talk a little bit about that? If you had actual discussions with the municipality, and you know how that arrangement would be?
So one of our industry partners is actually building a senior affordable housing building on the actual site, and part of that agreement was that they had to build a parking garage.
Okay.
So that's actually county-owned parking garage being built right now.
Okay.
So our building's roof did not have the capacity to produce enough solar for a building to be net zero. So we implemented it on parking garage because that helps the city's plan to implement an EV charging infrastructure.
Yeah.
And it also takes underutilized space and generates clean renewable energy.
So will they help front some of the funds for the solar array on the parking on the county?
So we included all of the costs for both the raise and our estimate.
Okay. For all.
So that would be the developer's money for our building.
Yeah.
Would be.
Okay, even though part of that is being funded by the jurisdiction by the city.
Yeah.
The parking garage itself would be.
The structure, but I'm talking in regards to the solar array.
Right, that would be, we included that in our calculation as out of our pocket.
Yeah, we're not sure how they're actually broken up in terms of if the city would pay for it, if we pay for it.
Okay,
We haven't talked to the jurisdiction about that.
Okay.
But we should include it in our final numbers for it.
Okay, and just to follow up on that real quick, what kind of payback period are you thinking you're able to achieve here on the solar array, and obviously the batteries you're.
Yeah, so for the system as a whole, it's about between 35 and 36 years as far as payback for the owner.
Oh, okay, thank you.
Mm-hmm.
Sure. I guess I'll have a question just for discussion. The incorporation of a library in 2022, it seems more and more challenging to have that type of building use because everything's online and digital. Why is that a necessary component of your building? And how does it relate to your occupants?
So we included a public library branch because our residents are senior affordable people that need affordable housing. And oftentimes affordable housing projects can tend to be sort of like put in a box outside of the normal areas of circulation. And so we liked the idea of putting our building right next to the busy Findlay Market and then having that sort of spill into the public library to engage the building with the community. And then the library also works really well for the access to resources, whether they're technology, whether they're like social programs or financial assistance through the library. The Cincinnati Public Library facilitates a lot of that, especially in more lower income areas. And so we thought that connection inside the building was a great way. And then on top of that, the social opportunities for the seniors who are often, lonely or having a hard time to connect with people. We just thought it worked really well. So.
Also, with the increase of people like working in different spaces that aren't office, we wanted to create an area that's like sort of a third place for people in the community to go to if they want to work on a project somewhere outside of the comfort of their home or in their office space.
I thought it was a really thoughtful design and really impressed with everything. I'm not as familiar with chilled beam technology, and I wondered if you researched examples of that. And certainly the connection with the windows is important because
we initially investigated 3 different systems and got rid of 2 of them just for various reasons. VRF we didn't do because of maintenance costs, upfront costs, and then embodied carbon with all the refrigerant. And then we also looked at geothermal, which was not viable on our site because it's so small and it's an urban environment. We want to do something with radiant because it's really comfortable thermally, especially for seniors. And we landed on chilled beams because it's low maintenance, pretty quiet, energy efficient. It is pretty high upfront cost, but the benefits, in our opinion, outweigh the upfront cost. So.
And instead of doing slab, we had a few like structural concerns just since we are a wood framed building, just with doing a concrete slab. And just since we're in such a humid area with humidity and like moisture control, we got rid of the slab element.
Yeah, and the operable windows are something that we think is really important for residential buildings.
Oh yeah, for sure.
And that was kind of needed in our opinion. And operable windows are only really be used in Cincinnati in like shoulder seasons, right? Because it's so humid. Yeah. So that's why we put the dry contact switch in there. Yeah. So there's no condensation or humidity concerns.
Yeah. No, I thought that was the thoughtful thing to do.
Speaking of thoughtful, what I really enjoy about how you framed the site and framed your spaces with the public courtyard and the private courtyard and engaging the community and giving the seniors a place to interact with the community. I think that's extremely thoughtful, especially when you go to your renderings and how they evoke the emotion of the space and the character of spaces that could be done. I thought that was very well done, especially how the architecture, I think it does kind of, it gives a strong backdrop for that feeling. And I think that was a really strong way for your design and how you're incorporating that. My question / observation though is about your unit mix. You decided to go with all 1 bedrooms. I mean, who does that target at a certain point? Because affordable, it doesn't necessarily mean that it's just a single or just a single couple. What about their families and or the visitor or somebody who may be just a single who wants a very small footprint or something like that? So I just want to challenge that mix a little bit more because I think you'll find some variety potentially, unless you had something. I feel like you got a strong answer for me.
I might have an answer. It's a great question though. It's something we wrestled with a lot at the beginning of it, which was there's a couple things. One, we were aiming for an affordable housing building because our industry partners are building an an affordable housing building, and so we were trying to be pretty conscious of like the repeatability of it, all the systems, all the constructions, all that kind of stuff. Yeah. And then the other thing was the sort of target demographic being seniors is that we find that in an area like over the Rhine, where the costs are increasing a lot, it used to be a fairly low income area and now it's quite fancy. Seniors are the most vulnerable population group to that because they can't go out and get another job. They don't have the same support systems behind them. And so we were really aiming for that, like either single individual or couple who are in their 65 plus to be able to move into here, where their kids might be a little bit more flexible and able to go out and figure something out. That was really our target demographic here. So
the only consideration about that though is if they're independent seniors and their kids are living in their own home, their kids are going to want to visit. And so I think thinking about that space and saying that the grandparents may have the grandchildren for a weekend, where the grandchildren are going to stay and things of that sort are just some other considerations when you think of senior housing or more independent senior housing, which is the reason why I think the mix can be varied a little bit more. I think I understand where you're going.
yeah,
And
no, I think
obviously,
that's a really great point, great observation. So thank you for that.
and then just getting into the minutia of your plans, because I think they're really, really, really thoughtful and fairly well executed. I think you just got to look a little bit more into the clearances. For instance, shoving the sink into the corner of your L kitchen is not exactly the best for mobility sake for as far as somebody coming into it. And so I think you can be a little bit more gracious, and it may make your units a little bit larger. But again, when you start to make the unit a little bit larger, and then you start subtracting and making a different variation in units, it could equalize out. But and this is just a random comment, is, man, for affordable, getting double ovens and it's microwave. Oh, really nice. No, I think it's really well done. I really love the character of the spaces that you've conveyed.
Thank you.
Thank you so much.
Yeah, can we talk a little about your exterior wall assembly real quick? You're gonna kind of walk me through that. So I get a 2x6. If you can just give me some more details when you say on the drawing 2x6 advanced wood framing. What do you mean by that?
So 2x6 advanced wood framing is a wood framing system made with 2x6 wood, and then it's 24 inches on center. So it increases the amount of insulation in the.
On center, which you mean by advanced.
Yes. Yep. It's the strategy for building that just increases the insulation to sort of overall increase the R value of that envelope.
Okay, and I see rigid there. How thick is that?
It's 2 inches around the wall and foundation, and then 2-inch boards on the roof, which gives it the high R value.
And you feel like you need that 2 inch because Cincinnati is not that bad of a climate. You don't think you could get away with a 1 inch of rigid? You guys ran it both ways. You feel like you need the 2 inches? Yeah.
I think we do. Yes, personally.
I vote for 2 inches.
It's pretty cool.
I guess
Yes.
I think the design was 8 or 9 degrees.
Yeah.
I'm Bryce, I'm glad you brought that up because
I'm asking an envelope question.
I know. The developer asking an envelope question. It's like, no, it was because the benefit of advanced framing you only get when you have like a large clear area of wall. And so with windows spaced pretty frequently, you're really not going to gain the benefit of it that you think you might. And then also with the brick cladding, brick usually likes to be supported at 60 inches on center and then maybe 2 feet vertically. So I don't know, maybe if you're increasing the spacing vertically, you can get the 2 feet on center studs. So those are just some aspects that I wondered if you've thought about or worked through, or it would eventually get worked through with the structural engineer or whatever.
Yeah, those are elements we definitely would have wanted to tackle in the future. There was a lot less of an emphasis on the structural design as like a whole building and more on the envelope itself for this project.
Yeah, and your written description of the envelope is a little better than your graphics. I think just you're gonna have sheathing in the exterior wall that you're not showing there, and we usually don't have house wrap in a roof or a foundation. So there's a couple other little things, but otherwise, I think they're good descriptions, and if I were consulting on your project, we could fix those things easily. So.
But riddle me this, and maybe you've thought about this, because this is more or less 3/1 because you're gonna have to have that separation. Is there a reason why you didn't, this seems like a prime candidate to go modular. Is there a reason why you didn't investigate going in that direction?
Yeah, so we talked a little bit to our industry partners, two of which are developers, and they've had some experience with modular construction. Two concerns they had are to do modular construction right, you have to like assemble everything 100% correctly, or it's going to be leaky. And especially with whether we designed our envelope using passive house strategies, infiltration is really important. So that was one concern. And the other concern is in our site, it's a pretty dense site. Streets are really narrow. So staging everything was another concern they had, especially in our neighborhood program.
And it rains a little bit there too. And we've had experience with modular in downtown Seattle, and the rain was an issue. The rain was an issue that we warned them about, but anyway, that's a whole other story.
I have actually heard that Cincinnati gets more rainfall than Seattle.
Yeah, no, that's, don't tell anybody, but it doesn't rain as much in Seattle as it does in some other places. It's just the more hours of wetting. That's the difference. Yeah. I don't know, what was the most challenging aspect of the project for you all?
Site and climate, 100%, I would say.
It was a north side, like a long north side, or north-south side. And so we had to do some tricky things because we ideally would want an east-west orientation. And so that was tricky.
Yeah, and then the urban site too was difficult with mechanical systems and geothermal, all that stuff. And then there's tons of shading buildings surrounding our site too. So that was difficult.
Just factoring in and see how realistic we could actually lower the like in such a condensed site.
Cool. Great job.
Yes.
Thank you very much. We can do the tech check for the Cooper Union if you all are here. If not, we will wait a couple minutes.
You'd rather the rain fall on the wooden framing while they frame the building than on a weather-tight shrink-wrapped modular unit?
It's a lot easier to deal with.
I was
Way
wondering
much easier
if
to
the
deal with.
modular.
I mean, the guys, the set crews doing their job, they're supposed to be.
We're just going to take about a 5-minute quick break and then come back for Cooper Union.
Weather-tight building. At the end of the day, the building is again weather-tight, and when they start again next day, right, I mean, they deal with.
There are lots of challenges with that. And it's just things that people don't anticipate, like the pick points. You know, how do you create watertight pick points?
Yeah, because now it's leaking through, and if you have your finish already inside that shrink wrap thing, now you basically putting of infiltration killed it.
Yeah.
Where what you're talking
in Europe that we don't do here. Yeah, that was one thing I learned in working with the folks at Google.
For decades, with more than 60,000 New Yorkers sleeping in shelters every night, a disproportionate amount of whom are individuals with disabilities or victims of domestic violence. Our design partners, JCJ Architecture and Barrier Free Living, are currently developing the Freedom Village project to remove barriers to success for these populations. Our goal is to propose a redesign that is net zero energy ready and improves upon their design while minimizing our carbon footprint. Our building is located at 270 East 2nd Street in the heart of New York City's rapidly gentrifying East Village. We are located in residential zone R8A. Because our building is classified as transitional housing, we have a maximum building height of 120 feet and an FAR of 6.02. Our site is close by multiple modes of public transportation, which allows for affordable and accessible transportation for our residents.
The building features a tripartite composition, which follows a zoning regulation that requires us to create a setback on top, as well as addressing the urban context on the ground level. This configuration allows us to divide this 10-story building programmatically into 3 parts. The ground floor with communal programs, the top floor with common area for residents, and the middle containing the residential units. The ground floor with communal programs such as offices for barrier-free living, offer job coaching and counseling, addresses the urban context by creating a thresholds in between
the building volume, and the street, offering certain privacy while preserving the continuity of the streetscape. The top floor promotes multiple forms of social gathering by having a combination of indoor and outdoor spaces, which benefits the targeted residents, such as people with disability and domestic violence survivors who are prone to loneliness and social isolation. The residential design features a double-loaded corridor flanked by a residential unit on each floor. All of the unit design follows barrier-free design principle, barrier-free living design principle, and are ADA compliant, offering a spacious living area with 36 inches doorway clearance and a restroom accommodating turning radius of the wheelchair.
To make sure that our occupants are receiving natural daylight, we performed a spatial daylight autonomy analysis using Cove's tool. And what this shows is that all the residential units will receive greater than 300 lux of daylight for at least half the time from 6 o'clock in the morning to 8 o'clock in the morning to 6 o'clock at night. LEED recommends solar glare of less than 1,000 lux for 250 occupied hours. What this shows is that we pass these LEED recommendations at 9%. Solar arrays are placed on the facade and the roof. The rooftop solar arrays will rest on a canopy system to allow for fire department mobility. So we use PV watts and Cove Tool's radiation gradient shown here on the left to determine the maximum solar, the best case scenario solar output and the worst case scenario solar output. And we got a range for this facade. And even what we found was that even at the worst case scenario of the solar output, we were only extending the payback period by 1 year for a total of 11 years.
A 60 KSI recycled steel frame will be used jointly with a CLT floor slab in order to resist gravity loads. Additionally, a 12-inch timber wall that's have been applied with weatherproofing elements will be used to resist our lateral forces. Autodesk Robot, jointly with New York City Building Codes, NDS, and AIC, have been used to design a structure. According to AAC 716, we're expecting wind loads of up to 130 miles per hour, which is why we conducted a detailed computational fluid dynamics to ensure that our facade elements and foundation can safely handle such loads. Going even back during Hurricane Sally in 2012, flooding occurred less than 1 block away from our site, which is why we're incorporating active drainage and a battery system in order to power up our critical systems. For our foundation, we're going with a 60-foot deep micropile foundation because of the presence of clay and a very high water table that made other foundation types unsuitable for the situation. Furthermore, steel members have been encased in fire-protecting material, and mechanical equipment have been mounted on the second floor to avoid any devastating effects that flooding might impose on those elements. For the roof, we are going with a 3.5-inch corrugated steel deck to ensure that the sustainability of the building and serviceability will not be compromised in the long run. This comes to a total construction cost of $378 per square foot, according to RSM's estimates. However, our partners, JCJ, estimate the cost to be as high as $460 per square foot. However, they're using concrete, which is slightly more expensive than timber, according to our research.
Conducted a life cycle analysis to evaluate the embodied environmental impacts. Disregarding operational emissions, the next biggest contributor is materials. And our hybrid recycled steel and CLT structure significantly reduces the emissions, with our wood only taking 27% and our metals only taking 4%. Some trade-offs were made, however, with our external walls and facade taking up 43% of our emissions by structural elements, and this was driven up by the robust insulated envelope. These insulation values were chosen to be above required values in climate zone 4A, and we're also using triple pane windows, and most importantly, an airtight membrane that reduces infiltration and thermal losses based on passive house standards. Air source heat pumps with coefficient of performances of 4 will supply heating and cooling through a variable refrigerant flow system to optimally condition each zone for the tenants with optimal comfort and controllability with either a remote controller or an app-based controller. Fixed bed regeneration provides ductless heat recovery ventilation. So each of these units are equipped with a ceramic core, reversible fans, and filters. And how this works is that when exhausting warm air out of the building, the ceramic core absorbs this heat. After a certain period of time, the fan will reverse, and our cold air from outside is preheated by this previously warmed up core. We conducted a first principles heat transfer analysis to evaluate the transient effectiveness of this type of technology. And we still, although a little bit less than typical ERV systems, we still get 70% heating and cooling savings compared to an ASHRAE baseline. Energy Star rated appliances and smart sensors reduce plug loads. And not only do we meet ADA requirements, but wireless controls for lights and automatic shutoffs for stoves further serve the specific needs of our occupants. A detailed energy analysis in Open Studio Plus, Energy Plus was used to size and select train heat pumps and also predict our total energy usage and occupant comfort. The model reports no more than 5% of the hours in a year being uncomfortable. And our EUI is 72 to 75 kBtu per square foot, depending on our solar outputs, just meeting the target for our multifamily building.
Thank you very much. Hate to cut you off, but you might get to get it all in when you have the juror question and answer, which we will begin right now.
Can you tell me more about this this fixed bed regenerator?
Yep.
I guess I'm just pretty curious. I've not really heard of this technology before.
Right. So most heat recovery ventilators, they use ducts, right, and either an energy recovery wheel or fixed plates. But we wanted to go for a ductless system, saving on losses from air leaks and insulation, and also reducing the cost of ducts construction and installation. So how this works is it's like basically just a cylinder that you put in your wall, and they come in pairs so that while one is exhausting and while one is supplying, you're not depressurizing or overpressurizing your building. And so we get this heat recovery while still being ductless and decentralized.
Is it automatic? Is it,
It's
you
automatic,
have a
yeah.
set
So it's-
point and you just kind of runs.
So it's
back and
programmed
forth.
to switch back and forth. Yeah.
Interesting.
And is it one per unit? Does it?
Right. So based on our energy model, we saw how much air ventilation was required, 15 CFM per person in the occupants. So some of the larger rooms have 2 or 3 pairs, but the studios have just 1 pair.
I noticed in your report that you guys were planning to use induction cooktops.
Induction cooktops, yes.
Did you guys run that as part of your energy model?
Yes, so that's part of our Energy Star rated appliances. Yep.
Okay, because those tend to be peakers.
Yes, yes. So
versus traditional electric cooktop.
Definitely.
So how you again, in a living environment like this,
Mhm.
the peaks are pretty predictable. Morning, but most of the evening when people cook.
Right.
So how are you going to handle? Let's just say an easy number. Let's say 40% of people are turning that on to cook.
Right.
The peak load on that building is going to be through the roof. How are you going to handle that peak?
So our interior equipment is our largest consumption by energy use. I think it's on page 31. But we're saving most on our heating and cooling losses. Yeah.
So how you gonna deal with that peak?
Handling with peak loads.
Yeah, that's gonna be pretty good.
Right. Our interior equipment is a source of loss. Yeah. But it's so densely packed. We're prioritizing our housing capacity. Yeah.
Okay, and just curious, why would you use an induction cooktop versus the regular electric cooktop?
So our stoves were selected and requested by Barrier Free Living. We really wanted that automatic shutoff because a lot of their previous buildings had fires due to their residents not handling turning off those.
So it's a client request.
Yes, it's a client request. Yeah.
Fair. Very fair.
Yeah.
One more time for me, just reiterate, who is the user for here? Who is the user for your building?
Yes. Kai, do you want to answer that, or Aviv? I don't want to take everything.
The target resident is It's transitional housing, so we're targeting either individuals with disabilities, victims of domestic violence, or people who fall into both of those categories, which unfortunately is far too common.
I hear that 100%. Wow. Man, my first comment will be, this is a really aggressive building, aggressive site, aggressive challenge that I think you've taken on fantastically. I think the density of information that you have as far as the technical prowl and calculations that you've done are phenomenal that are in this report. And I think that is a product of an aggressive site and aggressive nature. The part that I am interested about is when you talk about your wall section and then you talk about even this fixed bed regenerator, how does that all come together on your facade? Because you've got all these PVs on your facade and this angle, but how do those all come together? How do those all interact? Because you're gonna be puncturing them here, there, everywhere, puncturing.
Those are some of my same questions too. Yeah.
So if we look at the rendering, I guess. Slow.
And maybe I'm going to layer on top of his question.
Yeah, sure.
Also, is wood frame allowed for the size of building? It's one of my questions. Maybe does it have to be?
Yeah, we'll take that after this. I guess I'll pass it on to Ilias.
Okay.
Yeah. So in our facade, we can see there's these windows, and then the fixed bed generator fits in a part that is not covered by a window.
Okay, so it's just the solar panels offset a little bit. You have a little of your wall exposed.
Exactly. Yep.
Okay.
And then, can I say something from Zoom?
Oh yeah.
You have the slabs that will extend out, actually acting like a 3 to 5 foot cantilever, depending on the level at which you are. And the facade that holds the angled photovoltaics is a lightweight metal grid system that connects to angled clips that are on the underside of every slab. And the waterproofing is actually then recessed back a 1 foot offset behind that. So you have actually no punctures from the metal facade holding the photovoltaics into the because it goes directly into the structural slab, and the waterproofing is 1 foot behind where you have your curtain glass.
Okay.
So it's telling me here's the offset. Yeah.
Yep.
So I whoever was on the phone, oh, there we go. I can see you now. Great. First off, if you could say your name once so that everybody can hear that would be perfect.
Sorry, my name is Lionel Gilliard Schronenberger.
Cool. I just want to give you your props and your credit since you're part of the team. I think what would be useful, because you have a very thoughtful answer there, if we could see a section of that would be perfect to help, because you have the thoughts, you have the knowledge, and I'm sure wherever timing comes into play, but that is a critical detail for how you guys want to achieve what you're trying to achieve.
Yeah.
And then, wood framing?
Yes, please.
Hi, I'm Ilias. So to answer your question regarding the current legislation in New York City and CLT, it's a little bit of a gray area because there is currently work being done to try to adopt CLT in New York City because of the fireproofing capabilities. However, to my knowledge, the International Building Code has shown in many famous designs, such as the RISD project back in England, we have work done there. And in an interview with David Oben, who's an engineer at Otto Engineers, he told us that CLT has this ability, this charring effect, essentially, where it's able to hold fire for sustain a longer amount of time.
My question isn't so much about the CLT as it is the wall assembly being a wood frame.
The shear walls. The wooden
shear walls. No, just the wall assembly that between your windows, the opaque wall assembly, not the shear wall. You're showing wood framed walls.
Yeah, you got that exploded axon where you have the plywood and you're showing the 2x4 wood framing.
The wall section.
Ilias, I think I took care of that in our. I did talk about
right here.
New York City fireproofing considerations. The maximum fireproof rating based on the framing that we chose from New York City is based on 1 hour. And that is a combination of the double-faced 3/5/8 gypsum on either side of sheetrock. And that is the maximum rating that they will give you. Even if you were to say have fewer beams on center and have a thicker face-to-face wall section, New York City building code wouldn't even give it an allowance of saying 2 hours or 4 hours because they just cap their own requirements. So we exceed the requirements, but so the only one we can state is the 1 hour fire rating for all internal partitions.
The only thing that I would say that you would probably want to look back into a little bit more is the type of construction, whether it is type 1 or type 2.
This would be a type 4.
Type 4.
Type 4.
This is more than 85 feet according to the international building
So
code.
type 4C or 4?
Yep.
Okay.
Man.
Anyway,
Because the combustibles, the CLT is one side of it, but 2x4 framing and actually the plywood as well is another combustible that you're putting in the wall assembly regardless of the rating. So I think that's just something.
To be clear, this view that we have is for the exterior walls that are not load bearing.
Right, and that's what I'm talking about.
Okay.
Yeah. Your descriptions, your narrative was really good. I think some of the graphics were showing like 2x4 walls when I think your R values would actually require a 2x6 wall or something like that. But that's just, I said the narrative was there. Just the graphics was just the coordination between those things. Yeah.
Yes. Yeah, I would just say, I mean, we talk about more since we're talking about CLT and steel. When I see structurally combining the CLT with the steel, in theory, obviously doable, but it makes for a complex structure to do that and to merge the two together properly. Have you talked to a GC who's comfortable doing that structurally?
So we actually, like I was saying,
building a structure like that?
Correct.
Because in a perfect world, right, if the code was currently available, this should all be a CLT. It should all either be LCLT, it should all be steel. But I think when you combine those two like that, the GCs that we work with, I mean, it's just, it adds cost. I mean, because it's complex and they don't really do it, that means it's going to be a lot more costly.
Okay, so I sense like a 3-part question here. So let me bring it back.
This is more discussion as well, right?
We have it backed up. So let me start first by answering.
I'm just trying to understand your thought process.
Right.
And have you spoken to GCs who have actually done something like this, or they haven't? What were their response when you presented that to them? That'd be my question.
So to begin with, we reached out to David Oden at Oden Engineers, who worked on the RISD project, a very famous one in Rhode Island. And their project too was 55,000 square feet, which is very similar to our project. And they were doing this in the middle of the winter, extreme weather conditions. They did everything in just 2.5 weeks. So I don't think constructability time will be an issue in this case if they're able to do it in the winter. Because if you were to use concrete slabs, you would need at least 2 weeks or so for curing time in order for the workers to be able to walk on the concrete and set up necessary framework to create the next floor and so on and so forth. Furthermore, the labor required will be increased even more for concrete. In fact, I have some exact numbers over here.
So they've built this system before. It's been built.
It has been done before.
This height, combine those two together.
Yeah,
Correct.
think of it as like a precast.
This height,
like a precast plank, similar.
because there is the building is only a 5-story building. However, if we go back and look into, let me see here. We have an example of in Norway, Brumunddal, I think I killed that name. Just Starnet. It's an 18-floor mass timber building they're using.
I, as a developer in the US, I've learned the hard way to not mention projects in other countries.
Yeah. Sorry, anyone from Norway.
Canadians, even if I try to use Canada, usually it's right next.
That's the worst. That's the worst. Don't even.
I don't do that anymore.
Yeah. I had a question about some of the layout. I mean, some of the columns. Oh, go ahead.
Can I finish?
Yeah.
Sorry. So we also reached out to Bernard Gaffner, who is a senior engineer at Fast & Ebb, and he essentially gave us a few more of a breakdown of this cost associated with timber and concrete. And according to his experience in the industry, he observed that for concrete at least, although the upfront cost is only $42 to $46 per square foot, in comparison to timber, which is $48 to $56 per square foot. And that's not including an additional $1 to $2 per square foot for any additional insulation. The real savings come in the construction side. And he noted 25% faster than concrete in terms of erecting it and setting it up, 90% less labor force, and 75% less traffic in the area generated because of the tracks. Furthermore, like the cranes you use, you don't need as heavy duty cranes to install them inside. I mean, another saving, it's construction documents. You want to make sure that you are able to switch details on the fast because the contractor might see something in the field that's not currently working. You should be able to actually make these changes on the fly and don't fall behind on schedule when you do such projects. And in CLT, we have time, we have the cost. I think the next step is just legislation, bridging the gap in New York City and in the United States overall, making sure that the timber is also becoming more widely available in order to tackle these future challenges.
I had one question about columns in your living rooms.
30 seconds.
So just if there was a way you could design around that.
Sure.
For some of your units. Yeah.
Like the studio. Ooh.
Yeah. See, that would have tried a little harder to maybe design around that so you wouldn't have, especially for barrier-free access things, or some of these blocks.
So these columns have been encased in fire protecting material. We have also put some facade elements on this, or some cladding elements on the side to make them not look as ugly. And additionally, like Kai told us earlier, we have incorporated a 36-inch turning radius to make sure that people can move easily throughout the buildings. So I think that's not be a problem.
Excellent.
Zoe, can we say hi to Sarah and Sophia on their team for 1 second though?
Yeah.
You want to take another picture? So basically, next we have lunch. We will meet back here at 1:30. And otherwise, yeah, we can take a picture, we can say hi.
I mean, we're not going to discuss my questions during lunch, by the way.
Sarah and Sophia, you should just, you can unmute and say hello so you can get your 15 minutes of fame.
No, they can.
Hi, I'm Sarah Korezaka. I was in charge of the lighting system and the solar array system, and it was great to hear from you guys.
Cool.
Hi, I'm Sophia. I did the LCA and some of the appliance selections. This was great.
Cool. Very awesome. Good work, you all. Great job, everybody.
Yeah, thanks for joining us.
Bye.
Great job, everybody.
Thank you for your time.
You are welcome to the Richmond Cafe for lunch.
I want to take like a 5-minute, kind of breeze through to talk about.
Sure. Yeah, no, it's good.
Yeah. Before we get to the second half.
Yeah. Germany to run away.
All right, we'll go ahead and get started again. So welcome back to the multifamily building design competition. And our next teams are University of Missouri and then Ryerson, and then we're going to take another quick break. And then we'll do University of Arizona, University of North Texas, and Northwestern University. And then there will be snacks and networking again in the cafe. So get to go back and forth. I think that's pretty much it. Jers, are you ready?
Let's do it.
Okay. Are you ready?
Yeah.
Great. Please.
Awesome. Hello, my name is Lindsay Garbeck.
And I'm Brandon Johnston.
We are both seniors in the Architectural Studies Department at the University of Missouri. We are TigerNet. Welcome to the Gathering Place, a mixed-use, multifamily, residential and commercial building located in Columbia, Missouri. Our design includes 47 residential units, 3 levels of commercial space, a courtyard, green roof, and direct access to trails and parks. Our priority was to harmonize good design, energy efficiency, and sustainability goals. I'm our team leader, and our team consists of all undergraduate students. Our team is guided by faculty and mentor Lyria Bartlett, who is the head of the Architectural Studies Department at Mizzou. Our team also worked with local professionals to create our design proposition. Our site is located in a 4A mixed humid climate. Our climate is very unpredictable due to cool air shifts in the atmosphere. That being said, our design and system decisions are based on the climate, location, and annual precipitation of our site. Our target market is healthcare heroes in the Columbia, Missouri area. However, any individual can choose to stay here. With an intergenerational clientele, the Gathering Place gives users the freedom to share values of sustainable lifestyle and minimalistic mindsets. In addition, our site is walkable to Stevens College campus to the west and hospital campuses to the south, with additional amenities nearby. This site is an ideal setting for affordable housing, which is greatly lacking in the city of Columbia. To support the users, the Gathering Place gives our users freedom to pay off their student loans with lowered utility costs. The building lot size is 4.72 acres and has the capacity to accompany more buildings. That being said, an attached housing unit created by a Mizzou team shares the spacious site and amenities for its 24 housing units between 2 separate structures. Also, our site has the capacity to hold on-site composting, urban agriculture, solar canopies over parking, and 29 geothermal heat pump loops. Within our design elevations, we have highlighted important architectural features of the Gathering Place. With a predominantly southern orientation, we've maximized roof area for all of our PV panels. Also, we have included passive design strategies for heating, cooling, and daylighting. First, we dealt with passive strategies and minimized load sizes. Then we offset the remaining energy needs with efficient pieces of equipment. Also, in our facade, we have included a 20-degree gable roof and a light standing seam metal. We wanted to focus on our users' comfortability while achieving net zero energy usage. Within the Gathering Place, we have 3 residential sizes to choose from. All include passive design strategies without compromising on furniture replacement, circulation, or aesthetics of the space. Each includes pre-engineered dirt walls, which use low CO2 emissions and can be adaptable for users' needs without dust or waste. The only permanent walls within our space are for the plumbing, and those are stacked from one level to the next. Within our design, we have 3 commercial levels for the Gathering Place. The first level welcomes users to a unique contemporary restaurant with authentic cuisine provided by local suppliers and site-grown herbs. The second level is a food and shopping hall for local businesses to sell goods. And to accommodate large quantities of users, the Gathering Place includes parking below the central courtyard with 84 parking spots, as well as parking for bikes. The final level of our commercial space is a unique bar experience for our Columbia adults. To control the light within the space, we have included adjustable louvers on the skylights, as well as triple pane glass with a low E coating on the second layer. This bar opens out to a green roof, and this green roof uses native Missouri plants, which helps reduce the heat island effect.
Now, due to Missouri being in a 4A weather climate, we decided to use a combination of the Daikin horizontal system for our commercial space and the Daikin D superheater for residential. Alongside this, we incorporated a closed-loop geothermal heat pump system with vertical wells. The engineers recommended using wells 400 feet deep and spaced out 20 feet. These wells would carry clean water with 30% glycol. The commercial space uses a dedicated outdoor air system. We are using rubber subflooring throughout our design to mitigate thermal bridging between floors. We are using a combination of standing seam metal roofing and SIPS walls to achieve an R value of 40 for our exterior walls and 60 for our roof. We utilized a fluid applied vapor barrier and strategic window sequences. Standing seam metal roofing is a hydrokinetic material. This will allow for a watertight building while boosting the efficiency of our rainwater collection system. In addition, we have a storm shelter next to the underground parking. Missouri faces a multitude of natural disasters that may damage mechanical and electrical systems. Offering a secure place for residents to wait out the storm will offer a sense of security within our building. A Tesla Powerwall is tied into the PV array and can be used during these events. Our embodied environmental impact was supported through sustainable material options. The interior materials were selected with longevity and cost in mind. All of our materials are third-party certified and have low emissions. We are using dirt walls in our residential units. Dirt walls have a cost of $3.76 per square foot. This not only makes them a sustainable option, but an economical one for us as well. Our building's east-west orientation and geometry allows for the sun to provide natural lighting all year round. Utilizing cross ventilation during the warmer seasons helps us offset the costs associated with cooling our building. We have a 323 kilowatt array producing over 450,000 kilowatt hours annually. The utilization of air circulation and stack effect will ensure that our building's temperatures stay within a comfortable range. A design decision that we made in order to reduce our water usage was incorporating a rainwater collection system. This would collect runoff into our open air retention pond and then be filtered and used as gray water for our residents. We have placed a double-sided green wall in the center of a residential space. The green wall will act as passive air quality control and reduce our carbon emissions. Our residents will have access to smart features in their units, such as the Honeywell thermostat, and be supplied with Energy Star certified products. Our building has a HERS score of 49 without the use of PV panels, but with the use of PV, we were able to bring that number down to 0. Our building's EUI score is currently sitting at 8.11. We want to offer an incentive to our residents for reducing their plug load in order to promote a greener lifestyle. We want a design that enhances the health, wealth, and quality of life for our community. Thank you for listening to the TigerNet team's presentation.
Thank you very much. We can start the Q&A.
I'll start. Hello. Hey, hello. Hey. Hey.
How's it going?
Great job. Great
Thank
job. So I remember reading in your written report that you were planning on having instant electric hot water heaters. Did I misread that in the report?
Yeah,
In the units, the instant.
we are using it.
Yeah, no.
Oh, you're not.
We're using a DOAS system, and with that,
Okay.
we're using also the de-superheater within our units.
Okay.
And the de-superheater is attached to a water heater within each unit.
Okay. So it's attached to a water heater in each unit.
Yes.
Yeah, the de-superheater is an overall system that we're going to be using in our residential space. That mixed in, water feeds in from our vertical wells and will be pushed through, and heat transfer helps mitigate the cost of heating our water. So that's.
But so the water's coming to the unit at temperature already? Okay, so you said there's a unit inside, you said there's a heater inside the unit?
No.
No?
There's no heater inside.
There's no inside the unit. So the water, so if someone's taking a shower, people like to take extremely hot shower.
Mhm.
You're saying the water's coming to the unit at the desired temperature?
Yes.
Really? Okay. I guess I have to go, I'll let the others ask questions. I have to go back and see where I saw that. And I also think the water, you had calculated that you were 5 gallons per minute per unit is what you were calculated. That seems pretty high. I'm just curious where you got that number from.
Yeah, we actually
your
worked
call.
with an engineer when we were coming up with our different system choices.
Yeah.
And another partner that we worked with is HOK, and they recommended this engineer to us, and those were some of the numbers that he provided for us.
So the numbers of, because 5 gallons, that's a lot. I mean, there's residential homes that do not have wells that produce that much water per minute. So I'm just curious, in a unit for 5 gallons a minute, where do you see that water being used? And what?
Well, due to all of our residents, that would be My guess is from talking to the engineer would be under maximal load per everyone.
Okay. All right. I'll go find the, right, you guys go ahead.
Page 15.
Page 15?
Yeah.
So you did read it as well? Okay.
I have a question about your food production.
Yeah.
How much food production does your site have, and how did you determine to have that particular amenity for your project?
Yeah, so that was something that when we were first coming up with the design proposition is that we wanted to make sure that we had the agriculture and the urban agriculture that is on the site. And something that's really unique about Columbia, Missouri is that we're kind of, Missouri is a very agricultural state, but then also Columbia is kind of the center that's a city. And we have one of the best farmers markets in town. And so we wanted something that was a similar experience within the gathering place. And so due to the fact that we are trying to have these restaurants and that we are trying to have local businesses come in, we wanted to have the opportunity, not only that they can bring their own goods that they've farmed nearly 20 minutes outside of our location, but also that there's that on-site opportunity. So we have some of that on the west side and also between the two buildings. So since we have that attached housing unit as well as the gathering place, there's some extra space for there within those areas to have like plants.
Okay. Can you describe how the skylights and the louvers, how you figured those were going to work out, and kind of show me where you anticipate those, and those still skylights in the middle sections?
Yeah.
Are those public spaces below, or gathering spaces, or those within units, or? Yeah. Just talk a little bit about that area for me.
So those are in the corridors, actually.
Okay.
And so when you walk through, we wanted to make sure that we had natural lighting piercing through the buildings. And with that green wall that comes through the building, we also have, as you saw in that little graphic that we sent,
Mhm.
there is the balcony. So it does cut through the entire building. But also we do know that doesn't contain all the lighting, from level 4 all the way down to the ground level. But we have included in that green wall LED lighting, and that will help promote the greenery in that area. And for our skylights, we have included, it's a system that includes louvers, but they're also adjustable and they can open up.
So for our skylights, we incorporated solar powered skylights, then the louvers are on a mechanical system. So that way the building occupants, or building owners, I should say, are able to open and adjust those depending on the temperature within the building in order to activate our stack effect.
So are those areas kind of semi-heated spaces, or are those within the envelope, or is the envelope around the residential portions, and then
The
those?
envelope is around the residential portions with our corridors not being heated.
Okay. That makes sense.
Yeah.
Okay, and, go ahead.
Wait, hold on, say that again. The envelope is not
So-
around the corridors, but
Like the
corridor.
The corridor is outside.
They don't have
It's not
ventilation.
conditioned.
Yeah, they're not
Yeah.
conditioned, no.
So your enclosure runs around those parts. Yeah.
Yeah, and it goes into each unit, correct.
Okay. So it's more of an open air corridor type situation.
Yeah, and with that was a huge aspect for the passive design strategies. And we wanted to make sure again that we were focusing on passive design strategies first before moving into our active strategies, so that we didn't have to have as many active strategies within our system.
But that works for the top floor, right? That only works for the top floor of units. Any floor below that, they're not getting the benefit or gain of that skylight or that ventilation, correct?
So with that, as I mentioned previously, the green wall that cuts through, so it's a double-sided green wall, and then it opens up. So it's if you go to that slide, Brandon, that would be fantastic. What more? Nope, one more. There you go. Go to that last one. Yeah. So that's open up in the center. And so there's light that goes around. And so if you're staying there, but also the windows that are on the east side or the west side of the building, those do also open up for that cross ventilation throughout.
Okay, I think I see where my disconnect is. I think in your plans where you have the green wall, there should be an opening beside it so that there can be active or more or less an atrium coming through there. But I think there's not as much opportunity from what I'm looking at here is that I think you just got to look at the proportion of that corridor a little bit stronger, because where the unit entry is, by the way, unit entry is usually for units want to swing in. But you don't have enough space to transverse up and around it while also creating that opening. So I think that's just something that you may want to look at a little bit more.
Yeah, thank you for that recommendation. We'll definitely look into that even more.
So I found in your report where you're talking about the hot water, and you talk about the geothermal system has the added advantage of being configured through a fluid heat exchange to supplement the hot water system by routing excess heat to aid the tankless water heater. So that's the way I understood it. So I understood they're using the geothermal system to obviously have the water come in, not street water cold.
Yes.
Right, but then you're using a tankless water heater in the unit to then heat the water to the temperature as desired. And the reason I was asking for that is just in the energy calculation, because when we build multifamily units and to make it as efficient as possible and space-wise, we've looked at these tankless water heaters, but they're very energy intensive. They're called peakers. And so when we run our energy models, it's really hard for us to make the building net zero or net positive, because when those come on, in living environments in the morning, people take showers, and it's at night when they come home. And it's really hard to handle all that peak. So that's why I'm just curious the decision what you guys have made to use that.
Yeah, another fantastic thing. And again, after working with that engineer, obviously that was the best system that he chose for us and thought would be a really good option. But obviously there are challenges to the system that I think we may have overlooked or we may have not investigated as much as we should have.
Okay, and you guys had that in your energy calculations? Okay.
Yeah.
And how did you handle the hot water portion of the energy model?
So the energy modeling was done using Autodesk Insight. And with that, I inputted all the values individually with a cross-reference table and just went through and selected all of the fixtures and the hot water heaters and stuff. And we also looked at our EUI rating as well was calculated in that. And then all of it was manually input into there. And then the numbers produced are.
And have you just curious, have you guys looked at a heat pump water heater tank water heater with a heat pump on top, the new age water heaters or heat pump water heater? Have you guys looked at that?
No, we have not. We did not know that those were existence, but that is something to consider due to the fact we are using heat pumps too in Missouri.
Yeah, I think that might be better for you guys.
Thank you.
That's fantastic. Yeah, thank you.
I was just interested in the dirt walls. But it's a great concept, but go back to your floor plan there. Like it would be kind of fun to think about how or back to that, the one they had you different. Yeah. How would you see the floor plans changing? Do you think? Did you like? Yeah, because that was.
So dirt walls are actually the main advantage to them is they're easy to construct.
Yeah.
They're not so
You're
much.
talking to the microphone. Yeah.
Oh, sorry.
Okay.
They're not so much so meant to be, per resident, take down a wall, put up a wall.
Okay.
They're mainly just so that way we can reduce our carbon emissions while building it. And dirt walls are also sustainable in the fact of unlike SIPS walls, which is our example right there, you can't reuse those. Dirt walls, on the other hand, you can. So if we were to renovate, we would actually be able to take the dirt walls off. It's not an easy process, but it's still a renewable one. And then be able to reconfigure the apartments that way over a stretch of, let's say, 10 years before remodeling. And the dirt walls are aluminum framed and use a recyclable material. And that is exactly how they will look in our units with the finished side on the back, of course. Right.
Now you also have the movable walls, the movable furniture walls. in the units that you have, the dirt?
That's the dirt walls. Yeah,
Yes,
that's the
yeah, that's the
yeah.
dirt walls in the question.
So-
Yeah, they're not so much so movable, just renewable in the sense of if we were to do a renovation that we could reuse them.
Oh, because I understood them the way when I was reading the report that were actually foldable. They're also for foldable.
No,
pieces
they're
that
not. They're not foldable walls. But again, as you mentioned in our report, we can change those out if needed and if we do need
Got it.
compromise.
Okay.
So that is available for us. And we do have those on site for tenant ease.
Got it.
So yes, there are many opportunities with that.
Okay, so when on this picture here, when you're, I don't know if you have it in your, I can see in the slides. when you have
Yeah.
this part is as well. This is just built-in furniture.
Yeah, so that's the same
That's the same,
concept.
yeah.
Yeah, but you can reuse those, change those out, and if you have any damages, that can be removed for a sustainable approach. And
Okay.
again, they were created with low CO2 emissions.
Okay, and when you say, I think you said it was $3.50.
$3.76
a foot.
Cents per square foot.
Per square foot. So do you have any idea? I'm just curious on that per unit, what kind of budget to do this?
We did not calculate a per unit budget in order to incorporate the dirt walls, unfortunately. All of our budget was considered using the tally tool in combination with RS means in order to produce the values that we got.
So what I do really appreciate about the project is sorry, thank you. I really appreciate how you're weaving together the story of the commercial and the residential. I think it's a unique way to try to create a hub with those three stories of the restaurant, I think it was a shopping and the bar. I think that's really creative of trying to invigorate the community and draw the community in and create that type of value in the space. I think also how you're attempting to really break down the scale and use a form that I'm not going to say it's unique per se, but it is something that is has some type of value and let's say some look appeal that I think adds value to the site. And so I think what you're trying to do architecturally there is it's finessing its work. But I think some of the plans we could refine some of the generosity that, like with the green wall, I think you could find ways to carve that opening and make that atrium and make it more generous and make it, and then that could potentially help reduce some of the other corridors and that give and get. And then also some of the unit planning, I think just needs a little bit of finessing to actually to make that work, because I think you do have the opportunity of what you're trying to achieve as far as with the natural ventilation going through and trying to find ways to make that work a little bit better. But I feel like I'm about to get cut off. This is crazy. This is crazy.
How much time? Is it 5-0?
Oh, okay.
Sorry, I got carried away with the.
Thank you very much. Thank you, too. Thank you so much.
I think she was taking them all during the.
Okay, great.
Yeah.
Sorry?
They're going to that microphone there.
Thank you. All right.
We have a couple minutes, but if Ryerson is here, you are welcome to do your AV check.
I should find that page for me, because that's for a split second, I was like, did I have my wrong notes? Because I could have sworn I read it.
No, I was curious.
Yeah. I made notes as I was reading the reports.
Is everybody on Zoom from my team?
Yeah, I'm here. Samber, Aruba's here.
Yeah, I'm here too. Visit center.
What's up? Oh, yeah. You got the power. Okay, so Ruba, who else?
If you are from the Ryerson team and on Zoom, please put on your video. That will help me pin you.
Raj. I can never pronounce his last name. Hey, Raj, you shaved your beard.
Is everybody there? Right, great. Thank you, Jeff.
Let's check to make sure anybody who is remote that we can hear you. So just unmute yourself and say your name for a moment.
Hello, is this working?
Yep.
Yep, perfect.
Hello, everyone.
Hello. Hello.
Hello, this is Amber. Can you hear me properly?
Hello.
Yes, yes.
Like your background.
Hi everyone, this is Rajendra. Nice touch.
Oh, Raj.
Okay, can you guys hear if I keep my mask on?
Sure.
Cool. Just wanted to make sure.
I think
Thanks, Ben.
Be a little closer to the mic than other people, but
Yeah.
not quite that close.
Yeah, I just wanted to make sure it wasn't like super muffled or anything.
You're pretty
It's good. I think we're good.
Yeah.
No problem.
Okay.
This won't be as much of a challenge for you since you don't have a little to do, but especially during Q&A, make sure you're.
Yes.
We'll get started in about 2 or 3 minutes.
Oh, okay.
Relax.
Yeah.
I don't know what that means.
Yeah, tilt that microphone a little. It might probably help a little
Is that a little better?
Yeah.
That a little better?
Perfect. Yeah, it is. Did you draw the short straw? Is that why you got to come?
I mean, we're from Canada, so it is a bit of a trek.
Yeah. Well, there's a German team here too, so.
Yeah, we also met some of the people from my school, different team. We met a guy from India who flew here for this.
Oh, wow. Wow.
Yeah.
We added half the room so we can have people.
It's okay, I appreciate it.
I'll file that.
Just need a little bit of stand up, walk around.
Yeah, yeah.
Yeah. You guys good? Mm-hmm. Good.
All right, we're going to resume again the multifamily building competition, and we have Ryerson.
Hello, my name is Miles Asher, and I'll be presenting the multifamily housing building designed by my team at Ryerson University. On Zoom today is the rest of the team, Raj, Ruba, Amber, and Provis. Here's an overview of today's presentation. Each icon is representative of a different aspect of the competition. Any relevant icons will appear on each slide to demonstrate the interconnectedness within our design. Our building is located at 152 and 153 Dundas Street East in Toronto. It's right in the heart of downtown and surrounded by mid to high-rise buildings. The site area that we had to work with measures 2,800 square meters. Our design aims to reach net zero energy and carbon while keeping our expenses in check to provide affordable rent. There's an existing building on site. We decided to keep its historical portion but remove all of the new additions that have been added. Since our building is surrounded by high-rises, shading was an issue for solar power. We countered this by using high-efficiency tracking solar panels. The basis for our construction is modular. The basis of our design is modular construction using prefabricated mass timber units. We approximate that 61% of our construction is going to be done off-site to minimize disruption to the local area. Our building has a footprint of 1,127 square meters and 6,705 square meters of total floor area. 74% of our units are residential and the rest are either commercial or for building services. We balanced our mechanical systems with passive strategies to minimize the amount of energy used by our building. Similarly, we balanced high carbon materials with recycled and cradle-to-cradle certified ones. We incorporated several passive design strategies into our building. On the north, east, and west elevations, the window-to-wall ratio was 25%, and on the south, it's 40%. We greatly reduced thermal bridging by incorporating a continuous layer of insulation between the cladding and the prefab units. Our building sits in the corner of the lot, leaving room for parking in the back. These are the layouts for the basement and ground floor. The basement has several storage units for residents and laundry room. The ground floors are commercial area. Its interior is open to the public, but access is required for the rest of the building. These are the general layouts for the residential floors. The outdoor space will be in different slots for the floors not illustrated. The top two floors are being cantilevered over the existing building to incorporate better into our design. We have 4 different size units, a studio and 1, 2, and 3 bedroom apartments. The studio units are built together into the larger apartments and then subdivided into rooms. The floor to ceiling height is 3.4 meters and there is a curtain wall enclosing the atrium. On the left is the view from the Dundas Street entrance. The 505 streetcar runs along Dundas Street and stops 90 meters from this entrance. So this is the first view of the interior that most residents and visitors will get. The exterior wall assembly has an R value of 37.5. It consists of an outer layer of sintered ceramic paneling over mineral wool, a water and air barrier, and then the prefab units. The roof has an R value of 62. It's a conventional roof assembly with a 2-degree slope for water drainage. It's a very similar structure to the exterior walls, just a bit larger for added thermal protection. Our foundation has an R value of 22. Unlike the other assemblies, it's insulated with XPS because its water resistivity is better for subgrade applications. Along with the assembly shown here, the foundation is also embedded with bamboo poles as an alternative to rebar. Finally, our windows and curtain wall have an R value of 7. They're triple glazed and Passive House certified. Each building usage was designated as its own thermal zone for our energy model. Our HVAC system uses geo-exchange boreholes paired with heat pumps to heat and cool the building. The boreholes are located under the parking lot for ease of maintenance. Each unit has an ERV for humidity control and ventilation and a fan coil unit for heat addition and removal. The greatest heating load is in January, the warmest month, at 15 kilowatt hours, and the greatest cooling load is in July, the warmest month, at 14 kilowatt hours. There's a light fixture in each washroom, kitchen, and bedroom, and each living room and hallway has at least one. We used Energy Plus and Open Studio to model our energy use. We found that it has an EUI of 60.7 kilowatt hours per square meter, which is 73% better than the average multifamily building in Canada. Energy use is responsible for 2.2 kilograms of carbon dioxide equivalent per square meter. The heating and cooling systems use different amounts of energy to run. There will be enough boreholes for the largest value, but they'll be turned on and off using an optimal sizing algorithm to ensure the system is always properly sized. We were able to fully power a building using solar energy. We use dual axis tracking solar panels on the roof and fixed tilt tracking panels in a solar parking canopy. Using one-click LCA, we found that our building has 670 tons or 240 kilograms per square meter of carbon dioxide equivalent. That would put us in the B category of the embodied carbon benchmark. On the left is how our studio unit is assembled. On the right is our 2-bedroom unit, which is 3 studios across. Due to different orientations and window-to-wall ratios, some units might have different door and window configurations. To make sure the cantilever doesn't fail, the 3rd floor was analyzed using ANSYS. Due to the modular construction, proper tie-ins are required to make sure units don't move after assembly. In the basement, there will be solar battery to power the building for up to a week. Each unit will be outfitted with a recirculating shower system that is incorporated into a larger building scale system to reuse water as many times as possible. Residents will have access to an online building management system to let them into the building and to control their unit. Our materials cost is about $23.6 million or $327 per square foot. For your reference, here are our references. Thank you for your time. We'll now take any questions.
Yeah.
Thank you. As Miles said, we'll take questions.
All right, just so I can get this one out of the way. For this cantilever over top of the flared floor, I know you said you've tested it, but what did you test? What's actually supporting this?
So for the assembly underneath the floor, there's added beams at 24-inch on center to add more support. And then in ANSYS, I loaded it from the top with the fixed support on the bottom. Not underneath the cantilever itself, underneath where the building is. And we were able to load it, I think it was too far. There we go. It was able to take, I believe it's 100,000 newtons. I don't quite remember the exact number, and have a minimum factor of safety of over 5. So
kudos to you and the team for trying to do that and trying to think of the solution for that. I'm not quite convinced just yet that that's it, but at least you took a strong stab at it to make it happen. And I understand why, because of the importance of that kind of that historic building, which, you know, I think architecturally what you've done by pushing this thing back and trying to respect it on both sides is a very delicate way to form your building around it. And so I think kudos for that.
Thank you.
Yep.
Yeah, I didn't see in your report, or I might have missed it. I didn't hear the presentation. What are your planned market rents? What are you planning to rent these units for?
Raj, do you have that calculation?
I didn't get your question.
Yeah, I said I hadn't seen the report and didn't hear the presentation. What were you guys planning to rent the units for? What would be the market rents there?
The market rents for a 2-bedroom studio is around like $1,000, and 2-bedroom units is around like $1,200 to $1,400. Yeah, it's around like that. The 3-bedroom is around $1,600 to $1,800.
Okay, and is that, how much more affordable is that than the market there? Are these? I guess that's another question I had. Are these planned to be affordable units? Are they
market rate? Who's the
market
user?
rate?
It's comparatively to the downtown rate. It's more affordable than the baseline price right now in the downtown Toronto.
Did you have a target market of residents that you were shooting for?
Yeah, we're about a block or so from Ryerson University, and then 1.5 kilometers or so from University of Toronto. So a lot of the target for, especially our studio and one bedrooms, is going to be university students. And then the larger ones, if there's maybe a grad student or a PhD student coming with their family, or people who want to have a bunch of roommates and rent out with a couple friends.
Got it. And I get my other question out of the way. I know Michael will jump in and probably disagree with me, so I'll do a good conversation. I get why you want to do the outside and the outside installation at the site, but I would push back on that. I mean, having worked the last 8 years on modular, I would push back on you to do that exterior at the factory and have it finished on the site, actually on the reverse points. But I know Michael might have a different because it's not as, I know it's continuous. I know you probably want it to be more continuous, and you might push back and say, I don't.
What was your thought process behind that?
It was for the exterior. We have the exterior, and then in between the studs, we also have another layer of insulation there.
Yeah.
So we wanted the exterior layer to help prevent thermal bridging.
Yeah. But any good modular factory and set crew will know how to properly merge that all together. They do. I mean, they do solid zip on the outside all the time. Solid insulation on the outside of the factory all the time.
Can you clarify for me? I believe at one point you said the surrounding buildings were too tall to get effective solar generation through your PVs. And then I thought I saw another slide that says you were offsetting a bunch of the energy.
Yeah, so that was one of the challenges we had to work around, which is why we switched to the tracking panels. Because if we had just had fixed ones sitting on the roof, because the buildings around it are 20 plus stories, Toronto downtown, it wouldn't have been enough. So we had them tilt to follow the sun to get a greater output.
Okay.
Is a ground source heat pump system, is it easy to install in a downtown setting like that? Or was that something you all considered, or in looking at your systems, what systems were you kind of focusing in on?
Yeah, so for the boreholes, it's a vertical drill.
Yeah.
There's already some cleared parking space, and then after the newer additions are removed, there's going to be more space. You can put your equipment there, and then it's going to be going vertically down.
Okay.
Something that you didn't touch much on, but I think it's a strong design feature that you're trying to accomplish is these green spaces. Can you speak a little bit more on the intent and the quality of those spaces a little bit more?
Yeah, so I'm going to pass this one to Ruba. Ruba, you're muted.
Okay. Yeah, these spaces are found at each floor to compensate for the balconies because we don't have balconies. So it's for the occupants to socialize and to gather and to get a fresh air at the floor level.
There was a couple of things that I also saw, a gray water reuse system, which is something that we haven't seen much of. So can you talk about that a little bit?
It's actually really cool. I found this system last semester for a different project. It's a recirculating shower system. So as you're showering, it's refiltering the water. So the water that you use for your shower is like a set quantity, and they keep filtering it and purifying it. And then after you're done with your shower, you can then go use it to flush your toilets or to run your laundry or heat pumps here.
Yeah, I've heard of gray water reuse, but never for my own shower. so that was is it implemented? Is it available at scale?
Because we're going to be doing the shower system in the individual apartments and the individual showers. It's going to be installed in that individual shower and then feed back into the greater plumbing system.
Okay.
I have a follow-up question on your energy storage on site. I believe you said you have enough battery capacity to power every unit for a week. How does that cost impact your affordability for the whole entire project?
Yeah, so it is gonna add in, but we think that especially given Toronto winters and the potential for flooding with Lake Ontario right there, that it was important to have these kind of resiliency measures built in.
I just hope they're mounted like 5 feet off the ground, so.
Oh, yeah, yeah.
Okay.
You did a good job on your envelope and your control layers, and so I appreciate that. And your approach to modular was mainly because of the site being in downtown Toronto. You thought it would be a lot easier to construct using modular.
Easier to construct and
Much cooler. Yeah, definitely a cool factor.
Yeah, a lot of it was the downtown setting. Yeah.
But I guess what's more or less the inspiration of the envelope itself and the striated pattern and things of that sort with the reliefs? How did you come to that decision?
Are you talking about the architecture?
Yes, the architecture.
Okay.
Yes.
So, Ruba?
Would you please repeat the question?
What was the inspiration behind the patterning for the facade and things of that sort? I'm trying to understand what you were thinking of as far as to get to where you are now.
Oh, yeah, actually, because here we're using the module for the units, and also the facade is modular. It's 7.7 meter by the floor height. So that was the module for the windows. It's 1.4 times 1.8. So it follows the openings and the module of the units. And also it's based on the ceramic tiles or ceramic panels. It comes in different sizes. So this is available among the one that we used. It's from Ceramitics, a Canadian brand.
So you're reflecting the structure on the inside.
Yes, the structure inside, the openings distribution and the facades, and the manufactured module of the ceramic panels, the cladding.
So it's a really nice decision, and it's a really nice way to express the construction or the I guess the modular nature to the facade without just trying to smush it over. I think contextually it works.
Thank you.
Thank you.
I think you mentioned the modular boxes will be mass timber boxes.
Yeah.
So mass timber being CLT.
Yeah, so all of the studs and headers and things like that are going to be glue wrap.
Okay.
And then anything we use plywood for, like the walls and that, are going to be CLT.
Okay, and just curious, have you guys identified a factory that would build that for you? Have you talked to any suppliers who would
Yeah,
build
so
them that way for you with mass timber?
we haven't talked to suppliers, but we know that there's going to be a plant opening in Ontario very soon.
Okay.
I don't have an exact timeline, but within the next couple months.
Okay, and you think they'll be mass timber?
Yeah.
Okay.
There was a mention of a composting toilet at some point, but where did that show up? I think it was mentioned somewhere in the report, but I didn't really pick it out in the plans of the layout or.
Raj?
Yeah, like we were planning to have composite toilets and waterless toilets, which are high efficient. And we were planning to have the composite toilets at the lower level.
The commercial level?
Yeah.
Which level? Okay. I picked up on that.
And also the gray water, like which we were like originally Miles was talking about, like we were planning to install the treated on site, like which almost calculates almost like 80% of the usage. Mm-hmm. With basically calculating all the stormwater from with the loss to runoff and everything, like we are almost like getting like around 80%.
Amber and Provost, we want to give you a chance to say something. So.
Yeah, actually, basing off another question earlier about open green spaces and why we decided to go with emphasis on open green space, we wanted to have some community outreach or like assistance of some kind instead of just being an isolated building. We want to open it up to the public as well. So I just want to add that.
Can I add to the question then?
Of course, yeah.
And so how did you get to the proportion of the space? Because it seems very narrow and deep. How much light do you expect to get back there? Do you have any other strategies?
I guess, sorry, go ahead. I think Ruba can help me on this, but we do have a sunroof at the top to let natural lighting in. And we do have some deep lighting strategies, but I'm not too familiar with those. So.
I can add on that. Like actually, Ruba designed. If you look at the elevation, she has designed the open terrace. Ruba? Can you just give more on that? Can you add more on that, like about the open terrace? She punched on the envelope, but at kind of randomly, like to give cross ventilation. Ruba can add, Amber.
Yeah, actually, for the question is about lighting and ventilation.
Of the central space?
No, of the reliefs in the facade. There's those like places basically where you slipped out one of the prefabricated units. Those green spaces, they're just pretty narrow, pretty deep. You even added a header across the top to kind of limit some of the light. And I'm just wondering what are the strategies to get the light a little bit deeper in those spaces?
Yeah, actually, because we are using the modular unit, so it's just like taking one out and leaving this space like an outdoor space, and it's shaded from the climate conditions, so it will allow for the year-round use of the space, even if it's will not be totally lit at this depth. So we thought about it in terms of the occupant's experience rather than the lighting depth.
Thank you. Thank you very much.
Thank you, guys. Thank you all.
Thanks.
I keep cutting people off right when there's a lot of excitement about things, so I apologize.
We're just getting into it.
I know, right? You need 15
Thank you all.
minutes to get into
Thanks for
it.
being here online.
So we're going to have a break until 2:40 and meet right back in here, and then we will have University of Arizona, University of North Texas, and then Northwestern University.
Yeah.
Do we just start? I'm trying to see. Do we just start with this? Okay. Let's say that there. Thank you. Yeah.
We do it right things
Which is great. I will get word. Oh, yeah. Pressure passed out from the altitude, man.
All right, thank you for your patience. All right, we're gonna have 3 in a row now. So we've got University of Arizona, and then University of North Texas, and then Northwestern University. So without further ado, University of Arizona.
Oh. Zoe.
I'm so sorry.
Who was the one who just said that this was going super smoothly?
I jinxed it.
Yeah. He doesn't know. Don't you tell her. Okay.
All right. Hello, everyone. My name is Andrew Norris, team lead of the University of Arizona's multifamily building team, The Avenue. Our proposal is for an innovative mixed-use low-income residential complex that incorporates organic photovoltaics, generating a surplus of energy while providing shade in the desert climate. I'm joined by my teammates, Jonah Michelson, Nanvo, Alex Kaloje, as well as our faculty advisor, Jonathan Bean. The Avenue acts as an energy catalyst for the sunblock network, a concept of an interconnected energy collection and distribution chain created in collaboration with 2 other University of Arizona sunblock teams. We focus our efforts on creating passive building design with an emphasis on an airtight assembly and the elimination of thermal bridging. The project also aims to create a prosperous, equitable community, restoring traditional Tucsonan culture to the area. Our partners in this project include B Public Prefab, Eco Cladding, EC Nash Elementary School, and a potential local industry leader in organic photovoltaic such as Nanoflex. We also collaborated with the City of Tucson to ensure the Avenue achieves its goals. The site is located in Miracle Manor, a low-income neighborhood in Tucson, Arizona, close in proximity to downtown and University. The solar energy harnessed in the Avenue is enough to power the entire site, plus the cooling loads of 95% of the neighborhood.
Miracle Manor is a low-income neighborhood with a median income of $22,000. The Avenue will be an affordable place to live while stimulating a local economy and providing economic opportunity. With the average rent price of the neighborhood being $670, we understand that some residents cannot afford the suggested rent. Our solution is to work with the City of Tucson while obtaining grants from LIHTC and ARPA for residents who are in need of financial assistance. The current state of low-income housing is outdated, uninspiring, and does not raise the quality of life. Our solution is to redefine standards of low-income housing through creating a lively community.
The site is located between residential and commercial districts with EC Nash Elementary School directly adjacent. It was critical to the success of the project to integrate these districts and school into the program, enhancing the sense of community within the site. The Avenue restores historical Tucson values to the Miracle Manor neighborhood. The project uses a combination of color, landscape, and courtyards, connecting the user to Tucson's culture. Barrio Viejo, one of Tucson's oldest neighborhoods, is known for its colorful adobe houses, walkable spaces, and vibrant communities enriching the urban life of Tucson. The architecture uses colorful accents against white terracotta, projecting the vernacular building traditions of the Sonoran Desert.
The program combines residential, commercial, private mixed use, and educational spaces. Supermodules are organized through the site, creating 67,000 square feet of mixed-use space and 130,000 square foot of residential space. Courtyards open up to the public spaces, to the surrounding community, and shelter private spaces for residents. The spaces are connected through winding paths inspired by the Santa Cruz River in Tucson. The shifting of these forms creates circulation around the upper residential levels. Units come in 3 sizes: 1-bedroom, 2-bedroom, and 5-bedroom apartments. Open floor plans are designed, giving the residents the opportunity to customize their own living space. In this section, we can see the dynamics created by the architecture, including courtyard views, shaded rooftop gardens, and an integrated circulation system. ADA is accommodated with units on the ground level that exhibit larger bedrooms and bathrooms for appropriate accessibility. The construction assembly consists of modular wall panels from B Public Prefab, and a carefully designed engineered lumber floor and roof framing. This accounts for the structural loads created by the cantilevers. A radiation analysis was conducted to quantify the effects of the solar roof. The canopy lowers energy costs by shading the building from the harsh sun, allowing utilities to run more efficiently while generating usable energy.
Organic photovoltaics provide an earth-abundant, low-cost solar cell alternative reaching efficiencies up to 18%. This new and innovative technology is integrated into the canopy system, generating 3.1 million kilowatt hours a year of potential photovoltaic energy. The solar field covers over 178,000 square feet surface area of recycled plastic, which is used because of its material abundance and low weight, reducing the embodied carbon. The canopy is manipulated to more efficiently retain rainwater, which is then stored in water cisterns for future use. This water is guided off the roof into bioswales to facilitate vegetation growth.
We perform a WOFE analysis to determine that our design yields a site EUI of 7.29, meeting the FIA's 2022 criteria. The OPV canopy produces over 2.4 million kilowatt hours of surplus energy per year. Once the OPV is applied, the avenue will produce a negative EUI. The avenue acts as a small power plant for the sunblock network, generating enough surplus energy to cool up to 280 single-family homes in the Miracle Manor neighborhood. Use of the current technology and efficiencies of batteries, solar energy is stored in thermal storage tanks, allowing for easy distribution.
OPV technology allows the canopy to run efficiently, even on cloudy days and when damaged. In the case of damage, panels can be easily removed and replaced. The enclosure system was designed to reduce thermal bridging with a proper drainage throughout the roof and wall enclosures. Drainage mats and weather-resistant barriers are included into the habitable roof assembly, which is carefully detailed to reduce the possibility of leakage. We selected wall panels from B Public with an R value of R35 to insulate the interior spaces appropriately for the desert climate. Other important details include window and door connections, which maintain airtightness throughout the whole building. Flanged windows with custom shading devices integrated into the terracotta rain screen help achieve this goal. Continuous air and vapor barriers are also included in the wall assembly beneath the terracotta to ensure the enclosure performs properly.
Each module is equipped with centralized energy recovery ventilation, allowing for equal and adequate ventilation, providing excellent air quality. Heating and cooling is provided through an air-to-water heat pump powered by energy generating on site, contributing to the building's efficiency and sustainability. All utility systems run through two main mechanical cores. Passive design strategies lower the energy usage through building orientation, canopy superstructure, self-shading forms, and strategically placed windows to provide each unit adequate natural cross ventilation and daylighting.
We minimize the building's carbon footprint by using locally sourced materials found in Arizona and states nearby. Our tally analysis compares the construction efficiency of standard construction methods with our mode of modular construction. The results show that the modular construction has a much lower global warming potential. The ground floor exhibits a variety of mixed-use spaces that enhance the occupant's sense of community. Education spaces, fitness centers, small restaurants, and other spaces contribute to the economic prosperity of the avenue. The living spaces are designed to set a new standard for traditional affordable housing. We place an emphasis on flexibility in use and natural environmental comfort through the use of open floor plans. Achieving passive comfort reduces the need for task lighting and cooling demands, which lowers energy costs and makes living at the avenue more affordable to everyone. Energy efficient appliances lower the overall energy usage of the avenue, and educating occupants to track their own usage behavior and suggest efficient patterns in their daily living also will lower the energy consumption.
We believe that prefabricated assembly is a viable model for sustainable, affordable housing, showing how organic photovoltaics can provide energy at low cost. Pushing these innovative ideas, we are hoping to inspire the future of the built environment. Thank you.
Thank you very much. All right, time for Q&A.
Just like a half a breath, half a little step off, huh? I am more intrigued and amazed by how you are making use out of this canopy. It is baffling that you were saying that you can do, in addition to powering the site, that, what is it, 95% of the main? Yeah, that's making a statement out of the project that I think I can't get beyond right now. You know, at first glance, it's like, what in the world is this thing going on above? And then it's like, oh no, it has extreme usage and it has extreme relevance that I think to me is a very interesting take on how to achieve multifamily. I think a strength that you do have is the climate, where you can do more like open air corridors and things of that sort, so that you can have the passive ventilation and things of that sort. But kudos to you for recognizing it and taking advantage of it, because I think that that's what you're supposed to be doing. So I think, I mean, without getting too far, without getting too far and too deep into the architectural language, and we see the precedents, but why the white terracotta and the accents and the shaping of the windows? How did you get there, the shaping of those windows?
So the colors were inspired by the Barrio Viejo, which we mentioned in the presentation. And basically just the window shape, we wanted to add a little bit of contrast against, because it's such a plain boxy shape, we wanted to add a little bit of contrast and character against that. And we thought that was an appropriate use of inspiration. And the window framing is how we achieve that, essentially.
And is there a variable sizing of the window framing? Is there like a strength in the orientation based on where it's supposed to be in the shading, or is it really just an aesthetic feature?
It is an aesthetic feature. However, the canopy structure is manipulated in ways to provide shade to the windows that need the most shading. So for the western facing windows, the canopy is manipulated to take care of this.
So you put a lot of work into the canopy.
Yeah.
In Arizona, I mean, you talk about your air and vapor barrier. And are you using vapor barrier as more of a water control surface, or
like a water resistant?
Okay.
Yes.
Then you should use that term. Okay. Because vapor barrier it means something else entirely that you really don't need in Arizona, right? I think you understood the concepts and you described them well, and I appreciated the effort you put into the detailing. I also appreciated the historical building vernacular that you chose. So I'm not an architect, but I can appreciate that.
Yeah, good projects, guys. I really enjoyed it. Talk me through, have you had conversations with the utility company there? Because most utilities won't let you produce more than 120%.
Right.
Electricity on it. So talk me through conversations there and how you see it being set up with you actually creating basically district energy for the other neighborhoods next door. Have you guys had those conversations with utility companies? Have you kind of dug in there and kind of?
Not directly. So we are with two other groups at University of Arizona creating a network within this neighborhood called the Sunblock Network. And essentially what would be happening is we'd be working with TEP, Tucson Electric Power Company, to have them fund and own the solar canopy and all the energy produced from it, and then have them be in charge of distributing it throughout the neighborhood.
Okay, that makes sense. And then my next question, when you say affordable housing, what AMI are you guys shooting for? What segment of the population, average median income?
So the average median income of the neighborhood is $22,000, which is relatively low. And so our goal was to.
And you know what percentage of that of the average income of the area, of the entire area? Is it
of Tucson?
Yeah. Is that 30%?
I think about 30%.
30% AMI. Okay.
So yeah, our goal is to provide a living situation for those people, especially the demographics that are in Miracle Manor, with a lot of single parents with multiple children and potentially multi-generational families. So that's why we included unit sizes with 5 bedrooms and stuff like that. Yeah.
How many 5-bedroom units have you seen in Tucson? I've never seen a 5-bedroom product ever. Is that? No, it's a genuine question.
So they're only located on the second floor, so there's only 6 of them.
Okay.
So most of them are 1 and 2 bedrooms, but we felt the need to just provide enough space for, families with their grandparents or with multiple kids, and maybe coming from different cultures that have larger families.
That's an important distinction to make when you just, I wouldn't haphazardly just say 5 bedrooms because that is aggressive. I don't know if the market would ever support 5 bedroom, but if you say, but this is a family unit because it's meant to expand upon, I think then you hit a different sector, or you hit to a different home base that you're actually trying to get to. So I think that's important to clarify, and it deepens your story a little bit more.
A few comments. I appreciate your quality of your presentation. Personally, I found the key at the bottom. So as every slide went on, it kind of highlighted the topic that you were speaking upon. One of your slides showed what appeared to be some kind of smartphone app. Can you tell me what that app does, how the residents interact with it?
Yeah. So there's 2 main features on this app. One is for the residents who live there. They can log in to their home system, control all the thermostat, and the app is also educating them on efficiencies. So if there's a hot day outside and the sunlight is coming in, they'll get a notification to shut their windows or cover the blinds. It's also being open to the public, so the community around can be educated on the app, like the elementary school across from the site. It can tell them all about the integrated system, like the OPV roof panels and how much energy it's generating. Also like the peak cooling and how the energy is taking that out.
The main purpose of the app, though, is to lower energy usage by educating these occupants.
Yeah, that's good. Can you go to the wall assembly slide? It's a start. Yeah. Back to the one that has the exploded view. Oh, sorry. There. Yeah, was there a reason you chose for an interior air barrier strategy versus an exterior air barrier?
So the company we partner with, Be Public, they install the air and water resistant barriers for us into the wall panels. So that's just how it comes.
Okay.
Into the wall assembly. So
they've identified the interior plane as the air tightness.
Yes.
Layer.
Yeah.
And to piggyback on that, just curious, have you guys evaluate full volumetric modulars as opposed to panelized? Is there a reason why you went panelized versus full volumetric?
We did at the beginning. It is more. It's more customizable to use Be Public wall panels. We also.
What part of customizable was it? The width you guys were trying to achieve? Greater width, or
it's the architecture, it's the shifting in the forms that we're trying to achieve, like cell shading and all that.
Yeah. But there are variations of sizes of the wall panels and variations of R values. So we were able to find the correct R value that we saw fit through Be Public.
Okay, very cool. And then I just have one last question regarding this is going to be mostly a tax credit deal. Have you guys had discussions about the way you're building this project, and that have you guys checked that they would finance that type of build the way you guys are building this? Because that's been an issue.
Yeah, so one of our partners is actually in the city of Tucson here with us. So the next step would be to further investigate this process down the line, but this would happen right away if we wanted to do this.
What in your mind is the big innovation for this type of development or this community that you think will make a difference to to the success of a project like this?
So what I think what this project does really well is it is basically just a power plant in a way, obviously, and then has the multifamily building underneath. But rather than this just be like an individual project, this could be a catalyst for, expanding across the whole town and across the whole city. So this could be used not only just at this one site, but it could be brought along to help fulfill the energy needs of everyone else around the community. So I feel this is a big step into possibly, lowering all of our energy overall as a total.
What was the most challenging aspect of it that you had to deal with or address?
I think overall, you would all say the roof was definitely challenging to design overall and trying to figure out the best possible method to shade everything. So we went through multiple iterations of finding the best areas where we have certain areas where they duck down and curve, shade certain spots, and then also figuring out how the drainage would work with all these panels as well. So I think just the overall roof canopy system was one of the highlights. Yeah, we also had some consultation with some structural engineers to make sure that it's feasible. And so that took us a couple of iterations to figure out how to properly build this to make sure it doesn't like fly away or anything like that.
Cool.
Yeah, and I'm very intrigued with the district energy capability. We're building sustainable modular communities, and that's really our goal as well, is to produce more energy for the neighborhood around us. It's always the issue with utility companies.
Yeah.
And then also the loads. How can you talk a little bit? Do you envision batteries being on the neighborhood side? I mean, how do you envision the grid taking all that load? Have you guys?
So I think overall,
when you're especially down in Arizona, when all those, that's a lot of panels.
Yeah.
Right. And for sure, when it's going to be 2 p.m., they're going to be cranking power, and there's not going to be many people in the units actually drawing on that power. So I'm just curious if you had this conversation with the utility. Is there enough? Can they take that? Can they take that on the grid? Do they want you to put a battery on the neighborhood side? That's going to take most of the power. So for that evening peak, I'm just. If you had, it's not part of it, you can say, but I'm just curious.
We're still in the mix of getting it all, but from overall, the way it all works is that once that energy is taken from the solar panel, it's the DC energy is then converted, put through an inverter and change it to AC energy. And then that is put through an air to water heat pump, which then pumps that water and either heats it or cools it and brings it into the water storage tanks. So we would have water storage tanks located underground. And then we would work with the city of Tucson to possibly update our infrastructure so that water tank can be extended across the whole neighborhood. And then it could be used to power the rest of the community, as well as obviously our site.
Yeah, I was just going to ask about the tank, so you just hit it. Yeah.
Well, the city's here, they should totally do it. So. Yeah, this is what we want to do.
This is in your backyard. Yeah, it's all done. It's great.
Remind me how many units you have total?
We have roughly about 260 units.
Yeah, this is a big project. Yeah.
And is this near, or is this considered like a transit-oriented development?
Yeah, so it's on Miracle Manor, which is a historic road through Tucson where a lot of hotels and motels were located along the 1950s, and it's a very heavily traveled road. But it's in the vicinity, right in between the university and downtown, so it's in very close proximity. So it's in a very urban area where there's a lot of people walking around.
Okay.
I think going along with that, a big thing was the Avenue is trying to create a very bike-friendly and physical active community. So we do have enough parking for the residents, but really trying to make the bike community a big deal, because the walk score was a little low and the bike score was very good in that area, one of the best in Tucson. So just trying to stick with what's already there and enhance the area.
Great job.
Thank you very much. We have University of North Texas if you want to come up early and do your AV check.
That's the type of jurisdictions we look for. Yeah. Oh, died or something like that.
You know, with the air barrier, I was like, is that supposed to be like permeable or something? Because they put the air barrier in the back with the vapor barrier. I was like, is that supposed to be something?
Well, that's why I asked that,
Yeah.
because it really wasn't, it's not a air barrier.
No.
It's a weather resistant. It's the water, the physical water control there. And the air barrier can be inside or outside.
Right.
It's easiest if it's outside.
But I guess if it's fabricated or somebody can.
It should still be easy for them to connect it all up.
Yeah. So,
but little things.
Yeah, so that might have like 1 second. That work okay? So then for those of you who
this is the one that I was talking about.
whenever anybody has questions, within this line here, so that everybody can see you, and then more or less. Rennie will be over there with the reminders that
This is the one I was
5
thinking
minutes
about.
left, 2 minutes left, and then your other.
Test it out.
Testing.
Oh, wow.
Does it work?
Yeah.
Okay.
Let's go.
I think that's pretty much it. Is there anyone? Okay. Where do you want this? If you're trying to maintain. Second? Yeah.
Yeah. Yeah, what are we gonna do?
I'll
squat down.
Okay.
It has good pickup, so you don't have to. Yeah.
Trying to keep it as.
You can always James Brown it. Take it and toss it. That would be thoroughly entertaining.
Okay, does it work?
Oh, yeah.
Better.
Okay.
Yeah.
Nice.
Good.
All right, University of North Texas. All right, hello everyone. We are the University of North Texas Solar Decathlon team. And then this is our whole team together. We make up the Eagle's Nest. So at UNT, we are faced with a problem. The College of Engineering, also called Discovery Park, is actually a 15-minute drive, from UNT main campus. There is no on-campus housing close to Discovery Park. This is a major issue for students, and the Eagle's Nest is our solution to that problem. And on-campus housing that is close to Discovery Park, affordably priced, immerses students in the renewable energy research going on at UNT, encourages community and friendships among students, and of course, the local community, and yes, is sustainable. So right here, we have our site and climate analysis. We actually received 2,850 hours of sunlight in Texas. Yes, Texas is hot, but this makes us a great place for solar energy. Right here, you can see at the bottom left, how we actually angled our building to maximize wind energy production.
So as I mentioned earlier, Discovery Park is actually a 15-minute drive from the main campus. You can see the bus route at the right there. So as a resident of Eagles Nest, it would actually be a 4-minute walk to Discovery Park, eliminating the need for transportation, which of course is reducing emissions and saving gas money.
Each unit's about 700 square feet, and we can expect a cost of $1,300 monthly. It's about 20% below market value. Our construction costs are going to be $350 per square foot, which at 125,000 square feet, it's a little under $44 million. We expect this to be paid back within 31 years.
And these are our concepts and design goals, which we'll further expand on over the presentation. And these are the 6 main design features that shape our building. And this speaks to the amenities which on the site, which include the fitness trail and also our landscaping. The Nest sits on a 7.5 acre lot with a total of 95 beds and a 13,500 square foot of shared amenity spaces. And here are 2 of our 5 floor plans of the building. The first floor includes all of our amenity spaces, which is the collaboration area, our cafe, and our game room. And level 2 features our living quarters and the breezeway for air circulation. And note our sky bridge on level 3 with more living quarters that go all the way up to level 5. And on level 6, we have our solar array and also an amenity deck with a covered gathering space. And these are the elevation views over south and east wing, and the green areas are part of our air circulation. And here we have our UNT design wind walls. And the patio and the pool are just some of the amenities that the residents can enjoy.
New residents get welcomed into the Nest with beautiful sustainable finishes that encourage a collaborative and healthy environment. And while you wait for your laundry, you can play pool, games, relax, or watch a movie with friends in the pit. And you're tired of schoolwork, grab some coffee or catch up with friends while enjoying the living wall and finally finish wooden decor in our Energy Cafe. Moss, carpet, terrazzo, and a variety of the environmental friendly finishes of the spaces previously seen. Our living walls, a broad variety of plants on our living walls. Natural lighting helps purify the air, humidify the space, and is easy to maintain. And the Nest will provide the option of a 1 and 2 bedroom living quarter.
Some of our energy saving features are passive circulation, solar smart glass, as well as Energy Solar appliances. Minimal LED usage allows us to reduce our energy costs, and we can do this because of the shape of the building, allowing a lot of day lighting in. Passively darkened glass, as well as exterior circulation, further reduces our cooling load, and we still let in indirect sunlight so we can maximize our day lighting. Our ERV units are placed to minimize ducting, as well as maintaining a comfort level within each unit independently. PCM integration, as well as a radiant floor slab tied to our geothermal wells, further reduces our cooling load. And as you can see, our energy model predicts a UI of 27 prior to onsite, and our construction as well as energy performance meets with FIS 2021. Our most productive renewable source is solar, being in Texas, and as a result, you can see we eliminate 1,200 tons of CO2 per year, and within 9 years, all of our renewables will be paid for. A majority of our production is done in the summer due to it being solar, and winter as well as spring are some down seasons.
So the Eagles Nest will be collecting rainwater through the roof and through permeable concrete. The rainwater collected from the roof will be stored and filled on each level. And once those tanks are filled, then it will be pumped up to the water tank, and using hydrostatic pressure and gravity will come down and through the UV water filtration system be pushed out to residents in the different levels. Still, our overall goal is to reduce the water usage in the building, and we'll be doing this through using WaterSense certified fixtures, as well as the water cycle system right there that actually recycles gray water. This cuts down on our water usage by half of the regular demand in the US. So to the left, you can see the graph showing our demand versus the rainwater captured. The rainwater captured is not enough to fulfill the water needs of the building completely, so we're still connected to the city water.
Our wind system utilizes a UNT developed wind wall, which will output 20 megawatt hours of energy per year. We can expand this further with our stage 2 production.
Food production is a key element, so utilizing unfiltered water loops, we can water our gardens multiple times with the siphon system, and this will help provide lifestyle changes through community engagement and healthy nourishment to our residents.
On-site PV production gives us 289 megawatt hours per year. We can expand this to an additional 172 megawatt hours per year, and that's enough to meet all of our demands. The average person produces about the weight of a Volkswagen Beetle in waste each year, and we can leverage this into 18 megawatt hours of energy from biogas.
So next we'll be using a smart building management system for our HVAC lighting, access, and security. This will be used in connection with the Nest app, which you can see on the following slide, that offers automated tracking of apartment utilities, as well as a weather tracking software that makes energy saving strategies as necessary. This will also be used to give residents updates of what's going on in the Eagle's Nest. So with the Eagle's Nest, we are creating a culture of sustainability that actually encourages residents to be intentional with the way they use their natural resources. We expect rapid growth. Hence, our systems are built to be easily replicable and can be scaled up to meet the demand. This is an overview of our building construction materials. And here what we would like to note is our bio-based phase change material from Pure Temp, which actually absorbs and releases heat to maintain regular room temperature. With the systems we have discussed, we are confident that the Eagle's Nest will provide an innovative, exciting, and sustainable place for UNC engineering graduate students to call home. Thank you to all our sponsors, our faculty advisors, our mentors, and to you all for creating the space that fosters impactful engineering. Thank you.
Thank you very much. We'll do questions. Wow, you're all tall.
All right, go for it. You guys want? Half a second. Can you very quickly go back to the architectural page where how you oriented or got to the form? Because I know you went right past that fairly quickly. I just want to hear a little bit more about that, if you don't mind. It was early on. Y'all are moving mile a minute. Yeah. It was like there were 6 stages on how you got there. Yeah.
There.
There we go. Up, forward. It's all good. All right. Yeah, you're close. This one right there. Can y'all take half a second and guide me through this one more time?
So here we utilize our urban edge or rotate bar, and we wanted to maximize our exterior circulation. So we're trying to maximize our sunlight getting into the building, wind flow around the building, and positioning on campus. And all these features are things that we took into account. And this is going to help where we remove units and we add in our wind wall later in the slides. And our landscaping that we were also using our repurposed trees from the site. And this all went into account to choose this position and the rotation.
Great. Thank you. I just needed a little bit more of that clarity because I think how you got to your form and how you shaped this site, it was fairly well done, but you didn't give it its due and its justice. So I wanted to make sure that we saw that because I think how you strategically set up your paths for your exterior circulation, again, utilizing your climate to your advantage. Is this the first project that we've seen that has turbine walls utilizing the wind? I think that is.
Yeah. No question. I've never seen that. I'd like to hear more about that.
Yeah. I want to hear about this turbine wall.
Oh, yeah. This is a UNT development, right?
Okay, so the turbine walls, this is a UNT developed wall. This is a wind wall that's going to be placed on our east facade. This wall utilizes individual turbine structures on individual generators. And from here, I'm going to hand it off to our design engineer for this project.
Yeah, I design it.
Enough said.
I think it was a slide towards the end right there. Yes. Oh, there. No. Towards the end.
Oh, yeah, that's it. But it seems to have a dual purpose, at least from that one rendering, where it's providing shade
Shading.
as well as generating.
And that's on the
energy.
east side, so the morning sun.
So I would give you, bonus points for kind of having this duality.
Yeah.
Using your systems there.
So we design it using a steel rod with a rotary blade. And the rotary blade, their dimension is 5 by 8.5 inches. With the resistance added number frame, green.
Number 2.
Yeah. So as you said, it is used to shade the building, and we use it to make energy for our building and make it cool. With number 3, there's a mesh and the generator underneath where it rotates the blades. And we use the inverter AC power for end use. That's the whole design.
Have you prototyped it already? Is it something that you actually?
Yes.
It's something that you can actually produce and?
Yes.
Okay. And I'm just curious, so since you built a prototype, you know about what it would cost you to build that at scale, the wind
Yes,
wall?
the
And then-
wind wall, each wind wall, there's total of 32, and each wind wall is $2,500.
So obviously you run the numbers, you feel like it's, because to introduce that versus putting more solar, you've got to feel that that's going to produce power cheaper for you. I mean, I get the shading, that's one part, but I'm just saying producing more energy. Why would you introduce that versus paying for more solar? All right.
Okay. So we want to do that as part of a development program on campus. This site is meant to be a living and a growing site. So here we want to inspire our inhabitants to think and to grow and to develop the future. So maybe our first iteration is not the absolute best, but it is providing an opportunity for us to grow and continue to develop throughout our generations of people living here, working with these wind walls on a daily basis.
So it's more of a pilot.
Yeah, like a living laboratory.
Yeah.
Yes.
But for you to do that, I guess what I'm trying to ask is, and you guys obviously know numbers right, I do, to introduce something like this, it means that you think there's an opportunity to create power cheaper doing this wind wall than adding more solar. So you feel this is cheaper
with these wind walls.
Because as a developer, if I want to buy that system, you'd have to convince me that you can produce power cheaper with the wind wall. Putting the shading aside, to watch just production of power versus us buying more solar panels.
It might not be financially cheaper, but the footprint of this is much less than PV since this is vertical. It's really not taking away from our PV production at all, because this is something that can go alongside of all of our PV.
Did you buy that one? Because I bought that answer. No, I took that answer because that's what I was thinking in my head is you're using a different plane in a different space to generate that. But I'm with you.
I was talking about just power. I get
Yeah, I'm with you.
There's value there.
Absolutely, I'm with you there. I did have one more observation, but I think it escaped me. So I'll let you guys go. I'd like to hear more about the wall assemblies and the phase change materials, and I tend to feel like some of those aren't quite prime time yet, but be more of a traditionalist in my wall assemblies and look forward to more insulation and just those types of things. So explain that.
One more. There we go.
So we could have just gone with traditional continuous insulation there, but the PCM allows us to maintain a temperature distribution through the PCM during its actual phase change. And this is going to reduce heat flux and eventually flatten out sort of the temperature curve inside. And it reduces the peak load on our system and also allows us to sort of transmit heat into the unit once we don't need that anymore. So in nighttime or in colder climates.
Yeah, it's just a way of mitigating your
It's
peaks.
just flattening out our curves.
Right, okay. And the methane system, can you expand on that a little more? That's kind of a new one that we haven't seen yet.
So the methane system is basically going to use our waste So we have the people throwing away their regular trash. You have the compostable waste from the cafeterias and the cafe. And you also have the plant waste, which can also go into the methane pit. And what we're going to do is basically just throw all of our trash in there as our on-site trash storage facility. And we're just going to capture that trash. We're going to have some compressors. They're going to pull out the gas from the unit, transfer it to our mechanical room. And from there, we can transfer just the raw biogas without even separating it into some of our water heaters and some of our other on-site systems. If we want to use it in a more refined fashion, we could eventually develop a plant to refine the gas.
Is that tied to other research and work that's being done at the school, or is that just
Yes, it is. It's being tied into some of our other renewable energies and some of the research there.
Cool. And I'd read it and written down what I'd read in your report. I just wanted to understand a little more. You talk about the smart building management system that utilizes the Internet of Things and artificial intelligence to track energy use in building systems. Can you talk a little more about that artificial intelligence? Is that something you guys are proprietary developing, or what's that going to do? Just give me a little more background on that, on the artificial intelligence part.
So the AI system utilized one of our industry partners. We wanted to create a system that would be smart enough to track all of our inhabitants' phones, not from an invasive standpoint. But only from a standpoint to learn your user habits. What time are you getting up? What time are you leaving? After your habits are learned, maybe you leave a light on when you leave out. You forgot or you're
Are you
rushing.
just in the light for me, or are you sending me a text saying that I need to turn a light?
It can do both. Maybe it asks you a question. It's something that would be under development to see how much intrusion would you actually like. Maybe you want a text and you can go fix it, or maybe it says, do you want me to get that? And you can do it.
And this is developed already, so you're basically white labeling that, right? What you're doing, it's already.
This is in development.
It's in development.
Yes, sir.
With a partner.
Yes, sir.
All right, so.
Did you remember your question?
Yeah, I got it. And so I don't know if you stayed on this one too long, but your units. You guys went to a very, very compact unit, and I see that in your documentation. And I guess, for lack of better words, why? Why go so tight? Especially for student housing in a 2-bedroom.
In Texas, you get plenty of land.
Yeah.
Part of our goal was to encourage them not to just stay in their room the whole time. Our campus is right there, if they want to get out, they can get out. We have like exercise equipment around the facility, and sort of selfishly, this helps us reduce energy consumption by getting them out of the unit.
Footprint, yeah.
So really, we wanted them to spend as little time inside as possible. And that was a big part of it.
And also, something that is actually common in style is actually like smaller sized places like this, because students don't really need that much space. A lot of the time you're like living by yourself. I live in an apartment. I don't need so much space. I go there, I study. I'm honestly on campus most of the time. So there is no need for me to be paying for extra space that I don't actually use or need. So that's something we took into consideration. Yeah, especially for graduate students that are honestly going to be working in the lab most of the time on campus. Yeah, that's just something.
I feel like that's the famous last words. I don't need that much space. But also in a two bedroom in this specific situation, you can almost assume that's going to be roommate style. And when it's roommate style, you don't necessarily want them to share a bathroom, or you're going to have 2 unhappy roommates, possibly, unless it's utopian. And then, so I would just challenge that one. I can buy the 1 bedroom. It's very, very, very tight. And I think you may run into some anti-clearance issues possibly later. So we can work that out. But the 2 bedroom, I would at least try, or I would encourage the 2nd bathroom just for sanity's sake.
Okay.
Sounds like she had a.
Yeah, I was gonna say. Go for it. I'm tough.
Go for it. I live in and share a bathroom with my roommate, so it's not something that a lot of people don't want to do. A lot of people don't mind it. So I see some people might, but you're welcome to get like a 1 bedroom, but it's possible that some people don't.
No, it is very well possible. It's not like
In my experience.
not likely.
So I'll ask a question I asked everybody else. You know, what was the most challenging aspect of this for you all?
So you may have noticed that our narrative is a little different from some of the information presented in our final presentation. This is a first for us, and it was a challenge to get everything done, to do timing and logistics through the project. Focusing on our presentation, we neglected our narrative a little bit, and we didn't get the most updated copy submitted. That was probably one of our largest things to deal with.
That's a super honest answer.
Kudos to you for that.
I really appreciate that. Yeah, and I appreciate the work that you put into this too. It's helped flesh things out for me at least. Yeah.
Excellent.
Yeah. How about with the building? Or what else? Go ahead. Good.
Another obstacle there's 2 people they dropped from the designing team. So.
Yeah. Just real life stuff.
Yeah.
There's about 30 seconds if you want to continue on any obstacles or challenges.
The only obstacle we had with the interiors was just rendering them. Since the spaces were so large, is that just the computers were not able to kind of work through the renderings. So that was kind of a challenge for us to kind of work back and forth since we were both designing the spaces together. So.
And also one of our partners, she had to drop out too for like family issues. So that was kind of, yeah.
But you guys are all smiling at the end of this right now. It looks like you guys are having fun. You got a built-in roommate who will share a 1 bathroom.
Thank you very much.
I think we learned a little bit about Reggie as well, and not getting along with his roommates because of bathrooms.
You own bathroom.
So, we have Northwestern University up as our final presentation. If you want to do sound check and all of that, welcome.
It's a little better. It is. Yeah, it is better. That wind wall's really interesting.
Oh, shit. Oh, man.
Yeah. So if you're rotating, great. That's generally where we see you. Make sure to keep in and around the microphone during the presentation, and especially after the questions. It's really a good thing to remember. Want to check the slides?
Hello, testing. Is that good?
Push the microphone up a little bit. There you go.
Yeah, aim it at your mouth.
Hello. Good.
Yeah.
Is it coming through?
Yeah.
Okay.
Yeah. Don't be afraid to project though.
Yeah, all the way over, at least over there. So it gets back through. Now you can be over there waiting for a time check. You'll just take 5 minutes left and 2 minutes left, and you will hear the buzzer. Do you have any virtual team members?
I think there's just.
Okay, yeah. I can still pin them up there if you want.
Yeah.
To give them credit for what we're looking for.
I mean, I guess
not entirely sure.
Probably. Okay, if you are with it's Northwestern, right? Yeah, Northwestern, sorry. Northeastern, Northwestern. If you are with Northwestern, please put on your video and we can pin you up on screen so that you'll get some credit for being here.
I think this was another one. No, I'm wrong.
No, like, yeah, it's been really cool to watch.
Yeah, I'm glad that everybody's been.
I've been trying to.
It's been a lot of work.
It's our last one. Save the best for last. Starting to feel a little, lightheaded. Bedford Fuse gummy bears.
Yeah, I'm not sure.
Yeah.
We can start our final presentation by Northwestern.
Hello, everyone. We are Team Ingenuity from Northwestern University. My name is Robert, and with me here are my teammates Chris, Olin, Sahir, and Ellie. And today we'll be discussing our solution to sustainable and equitable housing in the US. Our team is composed of 13 undergraduate students from across engineering curricula. Alongside our design, industry, and faculty partners, we worked to combat some of the most pressing issues within the built environment. Buildings make up over 40% of total energy consumption globally, and with construction and demolition making up more than 2 times the amount of waste compared to municipal sources, it is clear that our built environment is in need of a major push towards sustainability. At the same time, housing costs are burdening many families across the country, especially in our cities. In Chicago, affordable housing is rapidly disappearing across Northside neighborhoods, exacerbating the risk of displacement in a city already suffering from segregation and a lack of diverse housing options. Our project sits near the site of Chicago's Cabrini Green housing projects. When these housing projects were demolished, over 2,800 families were displaced. And to this day, there are 85 families still on a waiting list, waiting for alternative housing to be provided. Other promises were also not kept up, such as less than 2% of promised jobs and contracts being afforded to local businesses. In the intersection of 2 major city streets and near the Chicago River, our site provides an opportunity to design attractive, sustainable, and affordable housing rooted in the urban and natural context, while providing crucial amenities for the community and neighborhood at large. Our mission was to design a multifamily building which maximizes sustainability and strengthens community. We achieved this through utilizing passive design, healthy and low CO2 materials, as well as our active systems. And we strengthen community through our equitable programming, affordable housing, as well as encouraging a healthy work-life balance.
Treehouse has a 2-story commercial podium with 8 stories of residential on top. 25% of the 160 units are affordable, and Treehouse is just over 330,000 square feet, has an EUI of -2.9, and has 51% reduced embodied carbon from the baseline. Now for our sustainable design approach, we first looked at the sun path and wind direction on our site and determined south and southwest facade to be optimal. Then from our alternatives, we picked massing 3 to have enough units, but also maximize envelope efficiency. Our sun studies and daylight analysis gave us our final massing. Moving on to the structure, the podium uses concrete to allow for larger spans in the commercial spaces while also providing durability and resilience against snow and road salt. The upper floors use CLT floor panels and glulam columns in order to reduce the embodied carbon, and a geothermal POW foundation supports the building and supplements our geothermal bore field. The envelope prioritizes continuity of the four building science layers. Our main insulation is mineral wool, which is fire, sound, and water resistant, and our terracotta rain screen guides water away from the building. Prefab saves us 20% in costs, accelerates our timeline by 20 to 50%, reduces our waste by 80%. Our prefab mega panels allow for the majority of the building envelope to be designed and assembled offsite. Our embodied carbon is reduced to the choices of mass timber, mineral wool, and refrigerant 455A, and other sustainable materials, giving us a 51% reduction from the baseline while also providing healthy indoor air quality.
A geothermal borehole field on the side of our building combines with the energy piles to provide geothermal energy, which integrates with the water source VRF system to provide heating and cooling, while a direct outdoor air system provides ventilation. Our PV system produces up to 2 million kilowatt hours of electricity per year. Our highly efficient LED lights, Energy Star's best appliances, and a variety of sensors all further improve efficiency. A baseline building has an EUI of around 53. However, with our sustainable systems, we can bring that down to 17. While we have additional energy consumption for things like EV charging and melting snow for our PV panels, our PV system can reduce our emissions significantly, bringing us down to an EUI of negative 2.9 and making us net positive. Furthermore, our PV panels will degrade over their operational lifetime, but we still make more energy than we consume, making 25 years of net positive performance guaranteed. Our PV system also can produce up to 70% reduced peak time grid loads during summer hours. Our water distribution system can take sink, shower, and washer water through carbon filters and UV disinfection for gray water reuse in toilets and landscaping. Combined with low flow fixtures, we can get 40% water savings. While our stormwater system uses flow-through planters that can capture 100% of the stormwater from a 100-year storm and forms a native plant riverscape, integrating with Chicago's Wild Mile project, a planned green space along the Chicago River.
Now moving on to our community design approach, the goal of Treehouse is to connect the previous Capri Green community with sustainability and social mobility. The first floor is our economic opportunity hub where local and resident-owned businesses create new jobs for our community. Treehouse has an indoor food court and a grocery site on site to provide easy access to healthy food. The second floor is our educations and healthcare hub, that provide educational and medical resources to our residents. Oftentimes, affordable housing offer only one bedroom unit, but Treehouse offer 1, 2, and 3 bedroom units at an affordable price to house bigger families with multiple children. To further increase the engagement between our residents, we also provide communal spaces within every 2 floors. Moving on to our environmental quality, the visual comfort is addressed through daylighting sensor, biophilic design, and operable shadings. Next, the thermal comfort and air quality is addressed through personal temperature control, operable windows, and MERV 13 filtrations. And lastly, our acoustic comfort is addressed through the integrations between mineral wool and thin concrete between floors that help to minimize vibrations.
Moving on to market analysis, when it comes to the city of Chicago, current rent prices are unaffordable for most residents. When it comes to our market rate prices, we determine them by referencing the Goose Island neighborhood that we are in and making it so that way they'd be 30% of the current income of that household. Whereas when it comes to our affordable units, we base that off of Chicago's $15 minimum wage, coming in at about half the price of the typical of the market rate unit. Moving on to price breakdown, the typical price for a building in Chicago is about $400 per square feet, and then an additional $30 million is added in terms of operation and maintenance costs over their 30-year period. Treehouse has a higher construction cost. However, it has a lower operations and maintenance cost, and it also has a lower cost for other things, specifically through prefabrication, low-income housing tax credits, and sustainability rebates, making it $114 million over its life period. With a net sort of like life cycle profit of $90 million, Treehouse is sustainable, affordable, and economically viable. Treehouse is a net zero, passive, prefab, resilient, and EV-ready building. It is affordable and features medical, educational, and economic community resources. Treehouse is a beacon of green infrastructure. It's time our cities turn over a new leaf with Treehouse. Thank you.
Thank you very much, and we'll do Q&A.
Anybody would like to reference, we have some of our project materials on the website. You can scan the QR code if you'd like to reference.
So I recall reading in your report that you were planning to do a rent-to-own program. Have you guys thought through because it's also gonna be a public project, right? You have subsidies for this, gonna be tax credits. Right, that's how you plan, you plan for the project tax
So we
credit.
are planning on using the low-income housing tax credits to help offset some of the costs because we have our low-income units. Rent to own is something that we're exploring, which potentially could be included to help build equity amongst our residents.
And will they allow that? Would they allow a rental program?
It's been done in Chicago before, we assume, based on our research. So we think it's something moving forward that we'll consider either having rentable apartments in like a normal sort of way or having more of a condominium rent to own option. That's kind of a further consideration.
You also talk about, you have a drain water heat recovery system that I was interested in your report. Can you talk more about it? And then kind of some of the costs and the expected return on investment on that? And the same question applies. I was just intrigued when I saw that, and I also saw the sink to toilet gray water system. Could you just talk a little more about?
So I can talk about drain water heat recovery. So I guess the idea would be that from our shower water, we could have like some sort of like copper heat exchanger and then feed that into the water before it goes into our tankless water heaters. And that we haven't done a calculation on the return of investment for that. It's one of the factors that we included in our energy model for helping to reduce the water heating related energy consumption.
These loops and then this loop you mentioned, the loop that you're going to be using, is that off the shelf? Is that something? Is that a system that already exists?
I think so. We've looked into systems that help. Do you want to talk about gray water?
Speaking more to the gray water system, the sink to toilet system was really developed because we wanted to figure out a way to reduce water waste. Typically, when it comes to sort of like potable water use, we end up using around somewhere between 20 to 40% of our potable water in ways that could be reapplicated and reused. So that was the sort of thought process behind that. Specifically, when it comes to the sink to toilet gray water system, it was ultimately that choice was ultimately made because we didn't want to waste money on piping, specifically on putting pipes throughout the building where we'd have to get gray water sent back up and sent back down. Ideally, we wanted it to be a top-down sort of system that would send gray water from residential units to a gray water treatment system and then send it out to commercial units and irrigation.
That makes sense. Makes sense.
Your building location is next to the river. And I know there's one or two civil engineers part of the project. Can you talk to me about some strategies to mitigate potential flooding along the river?
When it comes to strategies to mitigate potential flooding along the water control, something we wanted to do is we wanted to develop sort of like stormwater retention area. That's the sort of basis behind the sort of like flow through planters, where we wanted to have a place where water could sort of reside for a while, especially as storm surge becomes more common in the overall area. According to Chicago code, actually, you're allowed to send water straight to the river. However, we wanted to make sure that it would be something that sort of treated and well sort of organized before you could send it out.
Yeah, and just to add on to that, in regards to preventing overflow of water into the Chicago River, that was some of the design constraints that we were dealing with. The site has a really high water table. That's especially why we couldn't have a basement to our site, just to allow that that natural water to go through the ground. And then on top of that, like Chris had mentioned, we have other strategies that would incorporate also within the Wild Mile, which is a government planned initiative in order to rehabilitate the entirety of the Chicago River, because for many years it's just been like a corrugated metal sheet, whereas there have been plans to kind of turn it more into a natural ecosystem. People can, experience the river. It's not so isolated anymore.
Yeah, so with all that, I may have missed this, and you're gonna have to forgive me. You have a lot of commercial on these ground 2 floors, and you've got all these apartments. You can't build a basement. How do you deal with the traffic and I guess you can't have a car or vehicle living in this building, but how do you deal with, you're going to want a hub of this sort to have that type of engagement of people and others coming to the site. How do you deal with that? Or how do you?
Is this specifically in context to how people would get here and like the lack of parking?
It's both how people would get here, but then also how do residents deal with that as well?
Right. So I'm not going to skip back through this slide because I can if you would like, but basically the site is very close to several forms of public transportation.
Mhm.
And that's one of the things that we wanted to keep in mind when developing a project like this is that there's no need for us to encourage the use of individual vehicles when robust, commuter train rail systems as well as bus systems exist right next to the site. The corner of our site, the southeast corner of our site is a bus stop. So in terms of people being able to get there, it would be very accessible. And especially with things like the Wild Mile, there could be future forms of transportation along the river, which could also provide this as being a hub for people to come and experience just one of the many buildings that we hope to kind of encourage to become the new standard. One of the goals of this project is to kind of show that multifamily buildings can be built sustainably while still being very economically feasible.
It's good rationale.
I think we also, I might just want to add, I think we were looking into the commuter statistics, and something like only 20% of people in this area actually use personal transport, whereas like something like 80% use public transportation. We also do have a garage on like the northwest area, not a garage, outdoor parking area with 30 EV chargers, because we want to promote an EV future.
So there is some type of accommodations, just not, it doesn't need to be robust, but there is an accommodation. Okay, I didn't, all right.
Sorry, I misunderstood the question.
No, it's okay, it's okay, it's okay.
What was the inspiration for the wall assembly?
In terms of do you mean the assembly in terms of the layers that we have, or just the system, the way that the system works?
Well, the layers was one aspect of it, but also just the idea of like stacking these panels and then these large panels.
These panels?
Yeah.
Well, for one of the reasons was for prefabrication. We wanted to have reduced carbon emissions as well as save on the construction costs that would be associated with otherwise building this on site. Is this along the lines?
Yep.
So yeah, the idea behind using these mega panels is that by having limited amounts of construction that has to happen on site, we have a greater degree of safety for the workers. We lower the construction costs overall, and we save on the economies of scale that takes place in terms of producing this in a factory, and you could pump out these sort of mega panels at a much more efficient rate, as opposed to if the same wall assembly was being constructed on site. So we took that into account when kind of thinking about how we wanted to design the system. And in terms of the actual layers of the wall, that was just based on our climate, where we want to place the vapor barriers, making sure that we have enough insulation, making it structurally viable. One of the reasons that we have a layer of concrete on top of our CLT floor panels that serves the double purpose of reducing vibrations, but it also provides our mega panels a better place to mount into. That had a structural purpose as well. So yeah.
Having a couple, is it two layers of sheathing, and I was wondering whether or not you thought you could get rid of like the outer layer of sheathing and have a more of an intermittent cladding attachment type system, or if you looked at anything like that. I didn't know if the wind loading in Chicago wouldn't allow that, or.
Do you mean for the layers of sheeting? Do you mean?
Well, looking at looking at those details are a little different than the other exploded one that you showed, because the exploded one didn't have all the same layers in it.
Oh, for the actual envelope itself?
Yeah. So like in the report, you've got your steel frame wall, sheathing, and then your mineral wool cavity, and then more sheathing.
Oh, okay. Sorry, I misunderstood the question. I thought you meant sheeting, as in like the barriers, but you meant like the OSB.
Yeah, well, yeah, and then your weather barrier, I guess, is out on the outer layer of sheathing.
Yes.
But yeah, that OSB sheathing outer layer needs to get it structurally attached back somehow, and so how does that happen?
Yeah. So I guess for the first part of that question, why we had the two layers, that's mainly to have a cavity where the mineral wool insulation can be, because we can't just have it be openly attached. So it gives it sort of like a cavity where the mineral wool sits. And then in terms of how everything else is attached through it, we didn't detail it here, but I believe in our sections, it's there. So the steel studs would have a kind of Z bracket welded to them, and that Z bracket would go through the mineral wool insulation. It does provide somewhat of a thermal bridge. However, we don't have any other, for one, it's an industry standard because you can't necessarily mount the rain screen to.
You can.
just
But that's all right. No, it's the most straightforward way of doing
Yeah,
it.
it's the most straightforward way of doing that.
Yeah.
And so that's the option that we went with. And then,
No, yeah, it's a challenging assembly to think through and all the layers and you know, I can see that you've been very thoughtful with it and just wanted to hear more about that process. So.
we'd be very interested to talk more about.
Oh yeah, we can talk more later. Yeah. It's all good. Yeah. No, it's not easy. I mean, it's one of the more challenging aspects, especially when you've got an area like Chicago where you've got high winds and.
No, it's been a thorough presentation, and the report was very thorough.
Thank you.
Mhm. Should I ask my challenging question? What was the most challenging aspect for you all? Well, let's hear from Ellie in Poland.
I think one of the biggest challenge is the integrations of the Copernican community, because outside it has a bit of a history behind it, because it used to be an affordable housing that fell, and therefore a lot of people will move away, and then new investment came in, and they all built these expensive buildings, and more richer people.
Yeah, no, I appreciate that history of the project. That was really important.
So I think the biggest challenge would be to integrate more commercial spaces in order to make sure that our building is economically viable, to make sure that we're actually making profits at the end. After 30 years, we were able to make 90 million profit. So I think that was the biggest.
Okay.
Yeah, I think another big challenge, I mean, it was just such a large scale of a project. Like our project partner
Huge.
originally asked for 750,000 square foot building. And we were like, maybe not. Because we had a much bigger lot also originally, it like extended more to the north. And so we kind of scaled the project down. It was still really huge.
Yeah.
Last year, a lot of us did like single family home for this. So this was just a lot more to think about, a lot more integration of systems, things like that. Yeah.
No, you did a great job at scaling up. I mean, it's a massive project.
There's one last thing. We don't actually have an architecture major at our school, so all of us are like, I guess, hobbyists in terms of that. We have an architecture minor, so like that's kind of was also a challenge, like getting our vendors, getting Lumion for the first time this year. That was cool.
It was fun to work.
That's pretty amazing.
That's amazing.
I mean, that story in itself is really amazing.
Yeah, I guess like I guess like a final challenge we had was ensuring that we were providing enough spaces and amenities for people who specifically were in that prior sort of green context. I mean, especially understanding the history behind these things, such as redlining, and also this idea of, gentrification and like bringing in people. We wanted to ensure that we had community spaces that felt like they were places where everybody belonged, and ensure that these people didn't feel like they were, for lack of a better term, segregated from like the general surroundings. And that's why we have this sort of mixed market rate units. It's also why we have a focus on things such as education and office and access to economic opportunities such as maker spaces and things along those lines. So,
Thank you very much. You guys did a great job.
Thank you.
Thank you very much. Thank you to all of our teams. What a great job. Everybody really showed up, and this was really fantastic and answered some really tough questions. And jurors, thank you so much for doing so much work and really being present and asking all of the great questions. So just big appreciation to all of you. Right now there is for the student teams, networking and snacks back in the cafe, and jurors, we will convene here or wherever we decide. So thank you again.
Thank you.
Oh boy.